And good afternoon, ladies and gentlemen. Welcome or welcome back, if you were already with us yesterday, to this track 3 of our Endorse conference. We are going to continue going through innovation, new ideas, new solutions, new initiatives together all afternoon. And for that, I would like to invite our first speakers to join us, who will be presenting the Kohesio project. So I'm very happy to welcome Anne Thollard from the European Commission and Max de Wilde from the Free University of Brussels. Anne, Max, welcome.
Thank you, Florence. Good afternoon, everyone. I'm really glad to be there. I would like to thank, first of all, the organizers of the Endorse conference for the invitation. And I will now share my presentation. So we have the hard task today with Max de Wilde to do this presentation just after the lunch break. So I hope that you are going to like it and to embark in our journey, our Kohesio pilot project journey. So this pilot project started 1.5 years ago, more or less. And it was to respond to two questions raised by the general public and the European Union citizens. The first one was what Europe does in my region, so at very concrete local level. And the second question was, who are the beneficiaries of EU funds? And so in order to try and answer these two questions, we have started developing this project. So the Kohesio journey started with 3 DGs, 3 Directorate Generals in the European Commission. The DG Regio, so Directorate General for Regional and Urban Policy, DG Connect, and DGIT. We have also collaborated very strongly with member states representatives, mainly the communication officer in member states. And as data sources, we took the list of funded projects and beneficiaries published by the member states themselves, because they are bounded by the legislation to publish this information on their website, be it at national level or at program level. For the pilot scope, because indeed we are in a pilot phase still for Kohesio, we are covering 3 funds, the ERDF, the Cohesion Fund, and the European Social Fund, for 6 countries participating in this pilot: Czechia, Denmark, Italy, Ireland, France, and Poland. And finally, and this is of course linked to the topic of this conference, we have chosen, it was very important for us to choose an open source and a very flexible technology. So we have chosen to use a software developed by Wikidata, which is a Wikibase, but Max will guide you through all the technical details during the second phase of this presentation. So as a result, we have developed a nice, I hope, nice website that you can consult already, because it's open already to everyone. And so thanks to this website and information, you can now already answer the first question, which is what projects funded by the European Union are near me. So as you can see, there is here a very nice feature. And if you click on it, you can see all the projects around you. Of course, we don't have yet Belgium in the pilot. So we see only the project there in the north of France. You can also explore the project through themes. And we have an extensive also projects search functionality. And as we have translated all the project titles and description in English, you are able to search for projects. For example, let's look for projects related to robots. Here we are. You can see also all the projects on the map. You can zoom in or zoom out on the map. And as you can see, we are covering also outermost regions of Europe because we are covering also these regions that are linked to France. And of course, coming back to the results, sorry, I'm coming back to the map. You can reduce, of course, the search with, for example, robots, but for medicine. Then you have a smaller number of projects, and coming back to the results, you can click on it and have all the detailed information on this project, the description, the general information on the project, the funding information, the theme, and most interestingly, the beneficiary of the project itself. And as we are using this linked data technology and data coming from Wikidata, if you click on the beneficiary, then you can reach additional information directly in Wikidata. And so, as you can see, for this university, we have a lot more information, also some images, for example, and at the end, a nice list of identifiers, which were very useful for us because among these identifiers, we have also the EU Research Participant ID, and this ID helps us to bridge the gaps between different databases in the European Commission. So as you can see, I've just clicked on this identifier, and we are now in the research and innovation database of the Commission for the same beneficiary. So coming back to Kohesio and beneficiaries, we have also developed a beneficiary module where you are able to see all the projects and beneficiaries ranked by a contribution. And of course, you can also search for beneficiaries. So let's look if we have, for example, Amazon as a beneficiary. And so surprisingly, we do have something for Amazon. It's not really the Amazon we all know, but it's a beneficiary in the Czech Republic. We have enriched this beneficiary information, again, directly from Wikidata with this photo and the description. And we also have a link to the website of this school to check and to have more information on this beneficiary. So now you have had an overview of what we propose in Kohesio, in the Kohesio website. And for the more technical part, I will now hand over to Max.
Thank you, Elena. I'm sharing my screen now. Hopefully, you will be able to see it. No, no, didn't work out. Let me try again. Share screen. Okay, now you should see it. So as Anne said, we started from Wikidata because it's a very nice general purpose knowledge graph. But obviously, we couldn't really inject 700,000 projects and information like this into Wikidata because that's not what Wikidata is made for. But what we did is use the technology behind Wikidata, which is Wikibase. Wikibase allows you to set up your own knowledge graph, your own instance, and we install this on our servers, which is much more flexible because we can pull information from Wikidata, but also add additional information that is more specific or coming from Commission reference data. So we set up this Wikibase, and this is how it looks like. We called it the EU knowledge graph, not very original. And so in this knowledge graph, we have a lot of information that is already pulled from Wikidata, like information about institutions, European countries, capitals, and so on. But we also have information about the 700,000 projects and more than 100,000 beneficiaries, and so on. So this is very well. We set up this Wikibase, but at the beginning we had no data in it. We pulled something from Wikidata, but we needed also to import information coming from the member states, so the 6 member states covered in the pilot that Anne described. And so to do this, we had to go on the national websites because there was no single platform to publish. Each region and country publishes the list themselves. And for instance, if you look at this website for Denmark, you have a link here to download a list of all projects in a CSV file. It's already nice to have this, but it's not linked as such. So we had to download this. And the format is quite specific to each member state. There is no common template at this stage, and everything is in national languages. So all the projects are there, but here they are only in Danish. So you can have a look. We have all these projects, and sometimes we have some information that is empty. For instance, here, instead of providing the category of intervention, which should be mandatory, but it's missing. And so we also did some cross checks and we computed additional information to fill the gaps. And we have also indicators to do quality control, quality checks, and monitor if the amounts, for instance, are in line with the expectations. So this was the quality checks, and also now we are working with the local authorities in the regions and in the countries to work on a common template to improve data quality, and also with the help of the ISA Square unit in Digit from the Commission, we developed this validator that will help also the people in the member states to validate their data and make sure they are in line with the template. So this is nice, but the data was still in CSV, and we had to import it in the knowledge graph. So to do this, we used PyWikibot, which is a Python library provided also by Wikimedia Foundation, which allows to automatically import structured data into a Wikibase. And so we use this, we wrote our own bots, and we were then able to inject all this information you saw in the Excel file into our own Wikibase. So this looks very, it looks a lot like Wikidata, but it's not. It's linked opendata.eu, so our own knowledge graph. And you see this kind of information we have seen, projects in Denmark with a title, with a lot of information, financed by the country. The amount was originally in Danish krone, but we converted it also into euros because it's easier to aggregate across countries. We have a lot of information. The beneficiary was only a string, but we mapped it to Wikidata, like Anne showed already, to pull more information. We have very specific information. We had also a postal code, and from the postal code, we inferred the geo-coordinates. This was done on the fly also with the PyWikibots. Same thing for the summary. It was only in Danish, but we used machine translation to put everything into English, and so on. So we imported everything, but we also enriched the data at the same time. And since it's a knowledge graph, you can visualize the data in a list, but you can also visualize it as a graph. So here I start from the project and I could explore from here. Okay, this project is in this specific region of Denmark. But if I explore more, I can see other information about this and so on. This is, of course, the beauty of the knowledge graph approach. On top of this, we offer a query service. So it's a Sparkle endpoint, like the one of Wikidata. You can write Sparkle queries if you're familiar with Sparkle. Here it's a very simple query, for instance, to list all the count the number of projects in Denmark, and I have the answer here, 295 at this point. But additionally, we also offer the possibility to do queries in natural language, thanks to QAnswer, a technology that is converting natural language questions, so here in English, but could also be in other languages. You see that we can switch to other languages. And the answer is the same. So I asked how many projects funded in Denmark. The answer is correct. And we can also provide feedback to this matching algorithm. And finally, we also publish, we export all this data every night into both CSV and Excel formats, allowing people to reuse all this data. So you see here during the night, everything was exported. Every day it's automated. You can use all of this data. It's also already cleaned and put in a single format for these 6 countries. Remember that at this point, we only have these 6 countries, but we hope during the course of this year to add the other European member states. And finally, all of our developments are also open sourced and available on GitHub. Thank you. That was it. So if you have any questions, we'll be more than happy to take them.
Thank you, Max. Thank you, Anne. And indeed, we have received a few questions. And if you have questions, that's to all of our audience, please send them through the chat function of our platform. But I've already got a few here. The first question is actually to you, Max. And it's from one of our speakers later on this afternoon, Bernhard Kabina. Did you consider Semantic MediaWiki as an alternative approach when you looked into Wikibase?
That's a good question. And to be perfectly honest, when we started the project, it was already more than 1 year ago, we were not aware of Semantic MediaWiki, but we came across it afterwards, and we looked into also the interoperability between Semantic MediaWiki and Wikibase, because there is another project in the Commission that is starting now, and that will use Semantic MediaWiki. And so, yes, it's also, I think, a nice possibility. But for this project, yes, we had already started with Wikibase, and it serves exactly our needs. But indeed, we are still looking for what Semantic MediaWiki is offering on top of Wikibase.
Right, thank you. And I have another question here. Regarding the maintenance of a database such as Kohesio. I mean, it requires a huge amount of constant updating, clearly. So do you have a plan on how to keep it up to date automatically?
Yes, very, very good question. So we have already many bots in place that are doing exactly this. So for instance, if there is a change in Wikidata today, and this is something that could be interesting for us, it will be automatically pulled overnight and synchronized with our own Wikibase, unless there is a conflict. So we keep the possibility to have our own information. Maybe we need to keep precedence and to prevent overwriting our own data with the one of Wikibase. But if there is no conflict, we try to sync with Wikidata, but also with the data of the member states. And for this, the member states publish the data every few months, and we have already a mechanism in place to keep this up to date. Obviously, when we have 27 countries, it will become even more complex, but this is already foreseen. Of course, if not, the data risk becoming stale, and here it's really important to keep the data fresh.
Right. And if you want to add anything to what Max says, feel free, just jump in. I have a third question here regarding the Cordis platform. Cordis is clearly a platform that plays in the same field, but at a different stage of a project. So how do you see the development of the two platforms? Are there any scenarios where the two should be covered by where the two life cycles should be covered by one single platform? Or if that's not the case, what's the value of having two separate platforms?
Max, do you want me to jump?
No, yes, please, Anne.
Actually, yes, it's a bit premature question, but we have already discussed indeed with the Cordis team to see how we could integrate the two knowledge graphs and at the end have a seamless experience through the data we are going to present through the whole life cycle of common projects between the two knowledge graphs.
Okay, so that will give the answer to our query. And I have a final question, which is also in the chat. I see, what's the triple store running behind your Wikibase instance?
For this very good technical question, we have to go to the Wikibase data model. And so there is a triple store in RDF, but there is also behind so we use the Docker version of the Wikibase. And it's not only a triple store, there is also a MariaDB, a relational database, and also a JSON store. So they are using three data structures behind to optimize also search, to index a part of the knowledge, and then it's automatically exported in the triple store. And here, I'm not 100% sure anymore. So yes, there is the WQS and the Blaze graph that are available. That's a bit more technical. But if you go to the Wikibase website, you can see the technical documentation and what is exactly running behind the scene in the Docker container that is used to deploy the Wikibase.
Sorry, I think we have time for a final question. Have you considered using other sources of projects that are already aggregating the information from different funders like Europe PMC or Open Air?
Anne?
Yes, actually, we wanted really to as a first step, to focus on, let's say, the funds covered by regional policy. And so we focused more on the sources we could also enhance, so the sources from the member state themselves. And also because the member states are binded by legal obligations, so we were sure of the data source. But maybe at a later stage, we will see if we could maybe find synergies with other projects and open data source.
Thank you very much. I think we have no further question for the moment, but it's good that we had time to take several. So thanks very much for making your presentation shorter so that we did have time for exchanges. Thanks, Max. Thanks, Anne. And,
thank you.
And I hope to see you again on another Endorse conference in a couple of years, maybe. Ladies and gentlemen, remember to use the chat function if you have questions for our future speakers as well. We have many speakers coming up this afternoon, so please feel free to send your questions throughout their presentations. And also, we have an ongoing Slido survey, like we did yesterday. So on hashtag Endorse 2021, hashtag Endorse 2021 on Slido, you are invited to answer an ongoing survey. It's on all afternoon. So whenever you have a few minutes, please take that survey. I'd like to continue this afternoon by inviting our next speaker, Elena Simperl. Elena is from King's College in London, and she will be looking at crowdsourcing and citizen engagement. Elena?
Hello, good afternoon.
Hello, good afternoon.
I'm going to share my screen. You can see it now. Very well. So I am Elena Simperl. I am a professor of computer science at King's College, London. I have a background in ontology engineering and semantic technologies. But in the past 15 years, I've also trained as a human factors researcher because I've always been fascinated by the socio-technical nature of knowledge creation. In my work, I look at the human and social factors that impact how we collect data, how we organize it into using vocabularies or knowledge graphs, and how we use it in various purposes. In my talk today, I'm going to talk about some of my recent research projects, which have been in the context of smart cities. But the sort of methods and insights that I'm going to talk about are applicable, in fact, to any data or AI project where you rely on human judgments, for instance, to create training data sets, or you are, in fact, seeking engagement with different types of stakeholders to understand how they perceive the technology and the wider implications of this technology. My research is been carried out against a background of digital transformation. And many organizations in the public sector, in the private sector, have been undergoing it, and 2020 has certainly accelerated this trend. So the story is probably very familiar to lots of you. There is increased availability of data, devices, and internet connectivity, and technology, in particular AI, is disrupting how organizations work, in particular public authorities, from anything like decision-making to democratic processes. At the same time, there is increased awareness, especially in the public sector, that big technology investments need to remain people-centric. In order to ensure that they fulfill the needs and expectations of local stakeholders, of citizens, of communities, that they use data responsibly. And there are many examples that have been picked up in the media that show that people do care about what data we collect, how we structure and organize that data, and how we use it. Now, there is another argument for the socio-technical element of these sort of data and AI processes. And this community, the Endorse community that is looking at reference data sets and semantics, knows probably best that in many of these data and AI projects, in particular when it has to do with how domain knowledge is encoded, with semantics-based AI approaches, we do need human input. To create vocabularies, to agree on shared vocabularies, to curate data, to interlink data sets, and so on and so forth. And in the previous talks and yesterday, we have heard some examples about how this is done. The question really that I'm trying to answer with my research is, how do you manage these sort of socio-technical processes? What do you do when you have to rely on not just automatic tools and algorithms, but also people to carry out a data or IT project? human judgments and human processes are very different than automatic ones. Human labeling can be very precise, can be very context specific. People are fast learners, and we generalize well. For instance, it takes us 35 hours to learn how to drive a car. A self-driving car, by comparison, has been driving for hundreds of thousands of kilometers and still isn't able to drive. At the same time, human labeling can be error-prone, can be inconsistent, can be subjective, can be biased. All those sorts of idiosyncrasies that we know about human behavior apply here as well. Humans are slow, certainly compared with machines. So as we are trying to manage these sort of hybrid human automation processes, there are questions about how to make the most and how to use each of these types of processing, of knowledge processing organization to their best advantage. One way to mitigate such challenges is through so-called collective intelligence approaches. And there's various forms of collective intelligence. And in my talk, I'm going to talk about two of them. One of them is called online crowdsourcing. The other one is called citizen science. In both cases, I'm going to give you an example of a Horizon 2020 project where we have built a so-called socio-technical pipeline to create reference data to be used by public authorities, by researchers, in combination with machine learning algorithms to achieve common goals. So let's just start with crowdsourcing. Crowdsourcing refers fundamentally to an open innovation approach to solve a problem, any problem, through the help of so-called open crowds. This problem can be, for instance, the creation of a knowledge graph like Wikidata, which is created through a mix of automated bots and several tens of thousands of volunteers. For crowdsourcing, in particular online crowdsourcing, to work well, you need to have access to a large, diverse, easy to recruit crowd that can contribute various types of work to the project. In the case of Wikidata, you have a small number of very active editors, but you also have a long tail of casual editors who carry out tasks such as adding labels in different languages to the knowledge graph, introducing items, or checking how certain data ingestion pipeline works. Problems in crowdsourcing can be much more varied than that. So in the project that we have carried out recently, the context was transport and mobility. This is a Horizon 2020 project called Action that was completed in December 2019. It was also the runner-up for the Big Data Value Association Success Story competition last year. In a nutshell, the project built hybrid human AI pipelines to create and curate reference datasets for public authorities, in particular cities in Europe, in transport and mobility. What we wanted to do is to allow people to use crowdsourcing on demand to improve on the quality and the timeliness of the reference datasets they had to improve their mobility and transport policies. The on-demand aspect here is quite important because it differentiates online crowdsourcing, online paid crowdsourcing in this case, from other similar approaches. Public authorities do have existing methodologies to collect and curate datasets. In particular, they are using surveys. These, however, cost a lot, so you can run them only every couple of years and at small scale for particular parts of a city. At the same time, you could rely on, say, volunteer mapping, projects like OpenStreetMap. The problem there is the fact that you as a data publisher don't have much control over what the community is working on. So if you need to map a particular street on a particular day, if you want to update the information that you have about a very specific part of the city, you have very limited means to tell those volunteers who contribute to the mapping project from their own volition that they have to come and help you. There are certain things that you could do, like introducing incentives, and I'm going to talk about this in the context of a second project later on. But the other thing that you could do is to use a form of collective intelligence called online paid microtasks. So what we have done in the project is we have built a tool for public authorities, for urban planners, to be able to outsource these very specific on-demand data collection and curation tasks in transport and mobility. The tool itself is called Virtual City Explorer. You can install it, it's available open source, you can install it on your laptop. And as an urban planner, you use a digital street imagery. You could use Google Maps, but also any other mapping service you have. And you identify an area on the map. You decide what sort of information, the so-called points of interest, you want to collect. For example, this could be the location of mailboxes. It could be the location of disability parking spaces operated by private providers. It could be information about the state of bus stops and so on and so forth. Then you push the launch button, and the tool in the background outsources this task using a series of professional paid digital marketplaces that recruit people, so-called crowd workers, to come and carry out the task. And the task itself looks as follows. So as a crowd worker, you are going to see a version of Google Maps. In this instance, you are going to be placed at a random position in the area on the map that the urban planner has selected, and you are going to start exploring the city following the instructions that the urban planner has wrote. You are going to be looking, in this particular case, for bike racks. So in the city that we worked with, these sort of parking opportunities for bikes are operated by private providers, so that data is not available to public authorities by default. And we were interested to know where the locations are and what sort of capacities they have. So how many bike racks does each of them hold? So as a crowd worker, you go through the city like you would do on Google Street View, for example. And once you find an object of interest, like here, these bicycles, you have the option to take a picture using the shoot button here like you would do on a mobile phone. Then you submit that picture to us. We record in the background the location, the geospatial location of that picture. If enough people tell us that there is a point of interest at that location, then we have some certainty that that information is correct. If we want more certainty, we can add additional confirmation. We can recruit more workers to tell us more about the city. From all this information, we then we create a reference data set that is aggregated from the answers that are most likely to be correct. And in addition to this redundancy, there's also techniques that we are employing, which are called automated answer inference, which basically look at the distribution of answers for each type of question that we are crowdsourcing and compute the likelihood of the most correct answer. We have run trials in 2 cities, in Trento and in Nantes. In each of these, we have taken an area of similar size, and we have outsourced the mapping exercise to 150 remote workers that start at random positions on the map. If you apply this sort of online crowdsourcing, there's a number of things that you should check for to make sure that they work. So besides the data quality considerations, which can be solved with answer inference and redundancy, it's also worth exploring whether the task itself is feasible. So in our case, it was about identifying these sort of points of interest on the map and taking the picture. But similar approaches can be applied to anything from detecting sentiment in tweets, to typing entities in knowledge graphs, to integrating data sets, to doing record reconciliation. So making sure that people without any real expertise and context can actually carry out those instructions that you have written is quite important. You also measure for precision, and that precision is against an existing ground truth. In our case, we have looked at benchmark data sets that were already published by the public authorities in those cities and at OpenStreetMap. We've looked at coverage to make sure that people have actually found or have visited the whole area that we wanted to explore. And like with everything, when you have people involved, we looked at user experience. And the findings were quite positive, not only that the tool adds value to urban auditing methods, but also there's additional ways to optimize for larger mapping areas, which you can read about in a paper that is referenced at the end of this presentation. The second collective intelligence approach that I wanted to bring up today is related but slightly different, and it is referred to as citizen science. Citizen science originally is about scientific research that is conducted partially with the help of the general public. And there are many examples of that, but increasingly public authorities use citizen science and engagement to do evidence-based policymaking, especially in environmental sciences. This is a project that we've been running for a year and a half now called Action, where we are working with 15 citizen science initiatives that are run by science teams, that are run by NGOs, by public authorities in Europe, that tackle different forms of pollution. So in each of these pilots, people go and measure air quality in their area with specific devices. They go and take measurements of soil pollution in their backyards. They count dragonflies in a particular area in the Netherlands. Or they take pictures of street lamps to understand light pollution, and they submit that data to public authorities to create reference data sets. Unlike the previous example, where we have used payments and financial incentives to make sure that we have specific data collection tasks executed in real time on demand, here we're working with communities of volunteers, people who contribute to environmental challenges because they want to learn something about these problems or because they want to help towards a common good. So we don't have the same sort of lever to carry out specific data experiments on demand. What we do have instead is a series of other incentives. And in particular, we look at a class of incentives called gamification. For example, in Wikidata, if you want people to add missing information about people, or to add labels in different languages, or to carry out very specific tasks, you could, for example, use a game for a purpose. Here on the slide, there is also another very popular game in open data called Datapolis, which is run by the Open Data Institute. All of them have the same principle. So instead of payments as rewards, they use leaderboards, points, badges, competitions to drive participation towards a very specific type of task that people perhaps wouldn't, as they self-organize as a community, choose on their own. The challenge there is to understand which of these things work and when. And this is an example of a study we have carried out a few years ago with a citizen science team in healthcare that were creating a large reference data set for computer vision to create a map of the human brain. This was all designed as a game experience with various types of elements, with points, with leaderboards, and lots of different types of competitions. So our task was to understand which of these competitions work and whether the competitions do not deter people who just don't like competing with others and want to just casually contribute at their own time to engage. And the findings, so we basically had access to activity logs, so how people engage with that system. And besides interviews, we've also run different types of statistical analysis to understand user behavior. And the findings confirmed that even when people perhaps don't find this competition or prize incentive very compelling for themselves, they do, as competitions run live, as these campaigns are organized, participate more. So overall, there is an increased participation, both in terms of contributions and discussions on the side. Certain types of competitions work better than others in particular situations, and there's details about this in a paper at the end. And they also improve the skills of people overall. So just to conclude, AI data sets are created by people. Many types of data sets, knowledge graphs, knowledge structures we have heard about in this conference cannot be created by automation or by automation alone. So you will need some sort of human judgment. If you want these processes to scale, you most likely will apply one or different forms of collective intelligence. When you do that, you need methods to assess data quality, and redundancy and automatic answer inference are examples of such methods. But you also need to consider how different human processes are than automated ones. Consider, for instance, the user experience. There is another talk I give about how we've designed that picture, that shoot interface in the Virtual City Explorer, and how many other ways to submit the location of bike racks we have tried out. That's really important. At the same time, you need to collect data about how people behave so that you understand how to improve the experience and understand their motivations. And this is particularly important when people help you at their own volition, when they volunteer, because every type of additional incentive you would add on top of that may interfere with their original reasons to contribute, and you may end up possibly, if you don't have that evidence to study the design of incentives and their effects, you may end up with people participating much less, which is something obviously that you want to avoid. So thank you very much again for having me. There's the two papers of the two studies that I have presented, and I'd like to take the opportunity also to thank my team and the two H2020 projects that have supported this work. If you have any questions, I'd be happy to take them. Thank you.
Thank you, Elena. I think that was a very complete, very interesting, and certainly very concrete presentation with lots of very interesting initiatives and examples. So I'm sure you have inspired several of the members of our audience to try and implement similar projects. So thanks very much. I have not received any question. I don't see any in the chat, which means that your presentation was so clear that everybody got everything immediately. So that's great. That's a good sign. Thanks very much. And,
no problem.
And I think we can move on to our next speaker for this afternoon. And I would like to welcome Valérie Saintot from the European Central Bank. And Valérie is going to be looking at yet another aspect of interoperability, which, as you know, is one of the buzzwords of this Endorse 2021 conference, as we've been hearing since yesterday. So Valérie, hello and welcome. We cannot hear you. You have to unmute yourself.
Voilà.
That's it. Voila. Exactly. Welcome.
Good afternoon, everybody. Do you see my screen? Not yet.
Yes, we do. We have your screen. Everything's fine.
Okay. For a reason, I don't see my slides, which never happens, but I don't know what's going on here.
But we see your screen, but not in full view.
Okay, let me check if this is the reason why. Yes, of course, it is the reason why.
Very
Perfect.
good.
Then we are set to go. So basically, it's really nicely building on Elena's intervention, and I'm Valérie Saintot, the head of the legislation division at the European Central Bank. I'm also in charge of the function for legal knowledge management. And the last years we've been venturing and hoping to build on the good ideas we have and see how technology can help us. And indeed, we learned a lot. And as usual, one learns a lot more from what did not work so well than what worked wonderfully. So it's a little bit of an account of this learning journey through two chosen projects where we've been indeed realizing a number of shortcomings and understanding interoperability from a very broad perspective, really taking a notion that goes well beyond technology. What we've been realizing, so maybe a couple of data points on the two projects. So the first project was to retrieve out of a bulk of 1,500 PDFs, quite long, a number of, let's say, text segments, because we are always again and again confronted with comparable question or need to define again and again some legal topics. And we wanted to capitalize on 20 years of intelligence. And so we realized that there was this possibility to pilot topic modeling and looking a little bit what would be possible. That's the first project. It was done on internal servers, and it required the creation of a new taxonomy. The second project was a bulk of documents, many formats, and where we were actually interacting with some external providers. It was cloud-based, and these specifications are not just detailed because of the governance and all the aspects of data protection and so on. So, and there we combine existing taxonomies and ontology, and realized that we needed to create a new one, but did not go too far. So what did we do? Basically, part one, speaking of collective intelligence a moment ago, what is this collective intelligence in the case of our project? We had a network of agents, human ones and non-human ones, let's say either software, database, and other aspects. But we realized in this project that we need to look at the matter beyond just looking at the people involved, at all level of and in all their different specialities, be they data scientists or be they senior managers, within a specific unit, a specific institution, or across institutions. So we realized that actually we cannot just, in order to be successful, and that's, that's 2 years after we've been reflecting about all this. So we did not know that as we were going into these two projects. It's the learning we made running through them. And we realized that actually for this project to have any chance of success, one need to have a very clear map of the agents that are involved and not just be prisoner of a couple of pixels on the big scheme of things. We also realize that there are many, many layers of complexity. Maybe I am pushing open doors, but it cannot be underestimated. And I was quite impressed that every specialist was really very much in the space that was more naturally the home of that specialty. And that when you were starting to realize how many things needs to be interconnected and interoperable, you realize the complexity of the map of agents and their relationship between those who do, those who decide, those that are in front of the machine using the result of your work, those that are in the back of the machine programming the machine. And so when you start to really apprehend this, you start to realize, how can it be that with all the data we have, with all the technology we master, and with all the appetite that is abundantly at hand, that we are not bringing it so lightly together? There is another dimension, is we tend, when we have complexity, to reduce it and to oversimplify, and therefore to retreat in too small parts of the picture, missing out greatly on this complexity, and missing out on, of course, the challenge it brings, but also the opportunity, because all the project we've done in this area with ML and AI, we realize that it's by definition and by construct pluridisciplinary. So it really requires to apprehend this pluridisciplinarity, not only in terms of function and job title, but in terms of all the mechanism that needs to fall into place in order for any of these projects to have a chance to deliver on the great objective they set themselves to just deliver. So that's really a very important part, is absolutely have clear who are the agents, what are the layers of complexity, and how to avoid the trap of the discomfort of wanting it to make it simple. So complex problem calls for complex solution, in short. So I don't want to expand on the technical interoperability, because probably this is the most obvious and the most explored and encountered interoperability challenge that is faced by anyone venturing into the field of tapping data to gain insight and to reveal opportunity for better decision or for better prediction. We have that. This is a given. It's relatively well mapped, well explored, and well articulated. The second interoperability that we want to also kind of put in the foreground is the realization that the space between the human brain and the screen, to make it very simple, is highly underexplored. Many people speak of user experience, but they still look at the user experience from behind the machine to the machine, instead of looking at it from the brain of the user to the screen. And that space is a space with a lot of potential and a lot of opportunity that are to date relatively unexplored. What is neuroergonomics? It's, for instance, the brilliant genius discovery by the inventor of the tablets or the iPad, to name it, of swiping to move through the pages of a website or digital information. And that does not come from thinking of the user. It comes from really understanding how our brain works and how gesture completes and brings to knowledge sharing, knowledge consultation, knowledge production, a very different dimension than strictly neuropsychology can do. So when you look at neuroergonomics, you bring a piece in the puzzle or in the discussion that is oftentimes left out, which is the body, and not just the mind of the user, but its body. So the human-machine interoperability is crucial to any future chances of making big shift and real success. And then the third gap that we discovered is what we call human-human interoperability at the occasion of tapping data and advancing our different, whatever our problem is, and wherever technology can support us in advancing and in meeting our needs, we realize how much human-to-human interoperability is also little engineered and little explored or spelled out. And of course, it's vital. There we also notice an enormous literacy gap. So a very big challenge within the organization and with the service providers, that there is really many different perspectives and many different level of mastery, understanding, and so on and so forth, which creates many delink, many bugs. It's super uncomfortable to spell out a capability gap or capability problem at senior management level, at expert level. We all like to appear competent and potent, and when we discover that basically we don't know, we display all sorts of, unfortunately, not always constructive behaviors, and we focus, the machine did not manage, the data protection rule was not helpful, we do not have enough data, topic modeling does not work for the law, we do not have the right ontologies, and so we go into misusing technology to excuse our human-to-human discomfort. And so I just want to, we can surely expand on many aspects, but this dimension is definitely the heart of the message, to apprehend technological challenges, to use artificial intelligence to serve human intelligence and make the role of the human into the conversation at its best and tap its full potential, moving beyond possible discomfort that facing technological challenges bring. And so what I want to just synthesize for as a conclusion, through these two projects where we met really many challenges and very technical and a lot connected to interoperability, what we realize is to not only focus on the machine and the technology, but definitely look much more at the machine-human interface, and even more astonishingly at the human-human interface, where we realize that's where many blockers and many factors slowing us down and stimulating resistance. And therefore, we became adept of the PDF cycle, where we really stay as long as we can with what problem are we trying to solve, and we don't shy away from asking the question again and again. Really look at what is it that we need to know, and also all our blind spot, and find methodic to really gaslight our blind spot courageously, and then have many conversation in a true dialogue, which means crossing perspective, to gain insight, to facilitate in a very iterative cycle, prototype early, test quickly, look at the impact, and then wipe the board and start again, relentlessly venturing into having a holistic approach, and not just placing the human at the center as a good selling point, but placing the human as the center as the solution to technological interoperability problems. On that, I just confirm to you, this is a big job. This is a real job, but it's a super motivating one. And when you see that the machine and human team up, we get so much better and augmented opportunities that we learned a lot from being naive and hoping the machine would do so much for us. And we realized that actually the machine was challenging us very positively to upscale our intelligence or biological intelligence game in order to be able to converse with the artificial, a little less intelligent machine. So on these notes, I want to leave space for question, if any.
Thank you very much, Valérie. Just goes to show that it's not all down to AI and tech, and that the human factor still has a huge role to play, but not necessarily the most helpful role. So that was another very interesting presentation. I don't see, yes, I see one question here. Are the agile methodologies not the solution to this kind of issue linked to project management? Do you want me to repeat that? Are the agile methodologies aren't they the solution to this kind of issue linked to project management?
I will try to answer the question I understand. Basically, what we want to promote is the ability to really go for not being bound forever to your starting point, if I can put it that way. Because when we started, we were very convinced of our business case, our use cases, our proof of concept. And one project we tried to pursue to the end of it. And then we learned that maybe if we had redressed earlier the bar, we could have had another set of learning. The other project, we tried to adjust. Not that we were, let's say, got so fundamentally better result, but we definitely got fundamentally better insight and learning, and that the next opportunity to continue and meet the need that we have identified will definitely be done from a different perspective. So there I am really addressing the human perspective and promoting the idea not to neglect it and use the leadership toolboxes and technologies that help addressing this less spoken and less comfortable interoperability problem that I have highlighted today.
Thank you very much, Valérie. Thanks for all these explanations. And I would like now to invite our next presenter, who will help us look at information transferring. And I'd like to welcome Sabrina Medeiros. Sabrina is from the InterAgency Institute, And Sabrina, I could see you were nodding while Valérie was speaking, so clearly this was also speaking to you. So I'm sure that what you're going to tell us about is going to create a link with what we have just heard. So Valérie, are you there? I can see your icon, but I don't see you.
Yes,
There we are. That's
here.
it. Yes.
That's it.
Sabrina,
So
there you are. Yes.
thank you very much, Florence, and thank you also for the inputs on Valérie, because we are very much connected. Our, research understandings are very much connected. So I'm really glad to be here. Would like to thank the organizers and you as a moderator, and so that we can exchange ideas on a very important issue, which is conceptual and semantic interoperability. So my focus is on information transferring and the benefit of policy building. So I'm working on this quite, for some years. We are a group of researchers. First, we were in Brazil, connected to the Ministry of Defense. So we were working with the Army, the Navy, and the Air Force as to train officials to enhance doctrine compliance and doctrine understanding. So the work began with a very specific, job as to train people to be engaged in politics, in policy building in general. But then the challenges began to appear, so we were much more focused on behavior measures and behavior, enhancement than in defense properly. So we've worked in Brazil and then in the United States while I was faculty in the Inter-American Defense College in Washington. And right now I'm in Portugal. So I've been working with Portuguese institutions as to look, quite deep to the way information transferring is built and how we can organize it, how governance can help information transferring as not only to acquire, a better conceptual frameworks, but also to guarantee that those conceptual frameworks are derived from those, people's experiences, backgrounds, and bottom related experiences. So what I would like to initiate proposing that this research is basically based on practitioners' interaction. So, and how those interactions can add to semantics and interoperability. So it's not about semantic interoperability as a theme, but as to achieve semantics or frameworks of semantic based on interoperability. So interoperability as a way to achieve it. So the main concept of premise is based on this belief that policy building and policy effectiveness is dependent on the various forms of training and interaction. So we may have those interactive scenes or ambiences or environment which are purely nature, but we also can have environments which are especially created as to develop those conceptual frameworks from interaction. So we can use science both in understanding how nature and interaction can happen, but we also can guarantee that we create artificial environments as to observe how those conceptual frameworks are created and are also embedded in each individual culture, each individual path. So training and interaction may be political assets to permit not only policy incremental enhancement, but policy compliance. So as we see, policy compliance in special ambiences or environments, such as in defense and security, is very low, may be very low. So if commitment is not guaranteed in other ways, not only to assessing punishment regulation, as it is quite common, but also guaranteeing that people are on the same page, people can understand it the same way. And this is very much dependent, in my opinion, in our opinion as researchers at the InterAgency Institute. Those conceptual frameworks are very dependent in the political general understanding and the political framework that conditions semantics, not the inverse way to do it. So in our studies, we reached that strategic level policies may connect to micro policies, to micro policies. And those micro policies are not always viewed. So there's, a very low visibility of this policy incremental way to do it from the bottom side of the experiences. And if we can guarantee more visibility to this micro engagements, to these micro, policy arrangements, we can certainly guarantee that the strategic level is more connected and can organize better regulations and institutional frameworks as to guarantee a better compliance level. So in terms of peace and security within the Eurozone, we can guarantee that this qualification of concept and terms engagement is very important to permit policy reflexive building accordingly. So we are very much, attentive to this reflexive, building policy. And in these terms, for the next 10 years, we are talking about digitalization. So semantics interoperability and this digitalization seems to be a way to enhance semantic interoperability, but if it's not close to human interaction, so the human part of the artificial intelligence, so it's not going to be compliant with all the aspects of human aspects, moral and ethical aspects we want to. So transparency and citizens' participation may be also important, not only the practitioners' way to deal with this or their improvements, personal, individual, and collective improvements. So what about the procedures? So training tools to detect those good practices may be good for that. We had developed the ADAPT, which is the Agent Joint Assessment Planning tool. It's an open source tool. We have created this as to put our method in practice, so we could benefit from simulations. So using the wargaming theories and putting in those elements, those conjectures in as to be simulated. So using simulations, even artificial simulations, when actors simulate the other actors, so as to try to understand their conceptual frameworks in their mindsets. So may be a very important tool to enhance semantic interoperability. So agreeing on the various forms of naming tools, concepts, and behavior, and creating ways that semantic develop in an incremental way, so it can adhere positively to complex networks. So we are talking about complex networks. Those are two examples of simulations with the tool that we had done. So what about the ESCO method? Just to make sure we can use a case inside the European Union, the ESCO method is about crossing positive experiences. So what we can add from the ESCO in these terms? So semantic interoperability is seen inside ESCO like an active part of the integration process. So ESCO is dedicated to the job, to the opportunities and jobs networks inside the European nations. And this online consultation is a permanent portal feeder, and it's basically based on 3 pillars: skills, occupations, and qualifications. And it's important that they do this this connection in between concepts and terms. So skills conceptualization is also formed by social interaction, attitudes, and values. So what we can add to ESCO in terms of semantic interoperability. For sure, actors and states must be validating these conceptual frameworks that are being created, but still peoples and actors and practitioners must also participate during the whole process. So what we have in mind here, just to close it, is that, like the case, borders and integration policies or jobs-related networks, those all efforts that are being built inside the European zone can be added with simulations and work groups as to promote network and policy transferring and diffusion, so as to not only test those policy enhancements, but also connect terms and concepts to policy, which means contributing with metadata to also achieve higher levels of policy understanding, policy effectiveness, and policy, of course, transparency. So I'm very curious to hear from you some questions, and also here is my mail, Sabrina Medeiros, sabrina.medeiros@interagency.institute, and I'm very glad to be here again, and thank you, Valérie, and Fran, and I'm sorry. Thank you, my moderator. I just forgot your name, and I can see here. So sorry.
It's okay. No, don't worry.
Florence.
So, thank you. Thanks to you, Sabrina. I think you definitely helped us get a clearer view. And actually, I have two questions for you, and I think we can probably group the two. One of them is, what is ESCO? Is it a portal, and how is it structured? And the other question is, what's the relationship between ESCO and the Agent Joint Assessment Planning Tool, AJAPT?
Yes, thank you for your question. So ESCO has been a case that we are dedicated to, because it's a portal inside the European Union dedicated to organize the labor market, so offering jobs to people connected to various terms and concepts and skills. So they have these three dimensions, and they are trying to figure out how they can uphold, opportunities inside the European Union zone with those frameworks, conceptual frameworks, which means there's lots to do. There's a lot to do in terms of semantic interoperability. And what is the connection? We've been simulating using the ESCO terms and concepts as to test if officials in the various environments they can comprehend it the same way. So we are using the tool as to understand how understanding of conceptual frameworks may vary, and whenever they vary too much, there's a low chance of compliance. So if this is not built by those experiences in the land or in the bottom side of the way people behave inside the European Union, it may be released without connection to the bodies, to the local bodies, which means there's a low level of interaction and low level of compliance possible.
Right. Thank you very much, Sabrina. Thanks. And ladies and gentlemen, we're now going to enter our break and solution room for this afternoon. And I'm going to turn to our two hosts for that particular session. And it's my pleasure to introduce Szekacs from the European Commission and Robert Rovetto. Now, Szabolcs and Robert are going to take us from SMEs to the stars. We're going to be looking with Szabolcs at the interoperable mapping and SMEs. And then we're going to be talking, or hearing rather, about semantic reference for spaceflight. I will give the floor first to Szabolcs. Szabolcs, are you there? I'm trying to... Yeah, there you are. So thank you. Good afternoon and welcome. And over to you.
Yes. Oh, thank you very much, Florence. And thank you for the opportunity to present our project. My name is Szabolcs Szekacs. I'm from the European Commission, from the Director General internal marksmanship and SMEs, or DG for the background. We couldn't manage to have this beautiful Endorse background, so it's a bit more personal than what normally is anticipated. So today I would like to introduce a new project that we run in DG Grow. It's called the Common Mapping of Innovation Supporting Actors. And it aims at developing an interoperable mapping that provides information on innovation supporting actors. So as Ursula von der Leyen, our president of the European Commission, said in 2020, Europe's industry is the motor of growth and prosperity for Europe. And I would like to add that if industry is the motor, innovation is the lubricant that ensures that this motor runs efficiently, smoothly, and can answer to new challenges by competitors and new needs from society. For multiple decades now, since the Lisbon Council in March 2000, the European Union and also the member states understood the significance and the impact of a competitive industry, an innovative industry on society. So they spent a lot of effort on making this industry more competitive, more innovative. Most recently, in 2020, a year ago, the European industrial strategy has called for a rapid digital and green twin transition in our industry in order to create more value for our citizens and reach climate neutrality, while also increasing the competitiveness of industry. So this strategy recognizes the crucial role of innovation. Innovation, and especially technological innovation, however, is very resource and capital intensive. It requires access to funding, to testing equipment, piloting facilities, or market research. And then it requires even more resources to scale up the product that was innovated. So most of the SMEs lack either the financial or the human resources to do this all alone. So they rely on public or private funds, industrial intermediaries, such as cluster organizations or alliances to innovate. The current situation is that both the EU and member states provide many instruments that aim at eliminating these barriers. Initiatives also serve as yellow pages, so they provide information about facilities or test beds, technology centers that support SMEs in innovating. So the idea is that these yellow pages or phone books allow SMEs and intermediaries to find a suitable partner to innovate faster and more efficiently. You can see on the slide a number of examples, but these are only examples, so there's several more. Perhaps I can give a short description of two of them. The Advanced Technology Centers mapping, they provide information on how advanced technologies are developed and taken up by industry. And they also provide a lot of reports, analytical reports, workshops, and so on. But they also provide a yellow page on so-called advanced technology centers that can help SMEs innovate with facilities. The issue is that all these yellow pages, all this information about the innovation supporting actors is fragmented. So this catalog of innovation supporting actors only show a limited, fragmented view of all actors. It means that all these initiatives have to spend substantial effort to reach out to the relevant stakeholders, and that intermediaries and SMEs have to know what kind of support they can get from which websites, and they have to try to find this information. Sometimes all the information is scattered. For example, Advanced Technology Centers mapping, they provide information on technology centers, on facilities, while the EN network provides information on business intermediaries that can help you reach out and reach out to new markets. So the intention communication called Strengthening Innovation in Europe's Region recognized this issue and called for a more interoperable comprehensive map support actors. This call was born the common mapping of innovation supporting actors that aims at easing of data from innovation supporting actors across various European national websites. Also increase the data quality by elaborating a flexible common set of rules and descriptions for the actors and instruments. And it also aims to reduce the administrative effort and burden for the data providers, and also to raise awareness and support and engage stakeholders. How do we want to achieve this? By doing three things: developing a common interoperable data model, developing a set of tools that help SMEs, intermediaries to access the collected data, and a demonstrator website that shows the value of providing these data sets to SMEs and intermediaries. In addition, we also provide partner websites that would like to either share the data or reuse the data. About the interoperable common data model, we aimed at making this tool as interoperable as possible to allow for it. We identified common attributes and developed the model based on standard schemes and ontologies, such as, for example, the ISA stories or the W3C organization ontology, and so on. We have included common attributes that we found with all these partner websites, such as the name of the supporting actor, description, location, different classifications. But of course, we also realize that there are a number of very large variety of information that is available on these actors. So we try to make the model flexible and extendable enough as well to counter for these variations in the data that can be provided. So, for example, the data model is flexible in the way that data providers are allowed to either use our own common taxonomies and ontologies, or if they have their own proprietary ones, they can also encode the data using their own taxonomies. They can also extend the model with information which is not common for all the other websites. This common data model is already developed. It's available under JoinUp. You can see the link below, and it's freely reusable. It's published under an open license. In addition, the project develops a number of tools to help access the collected data. We developed first downloadable data sets, so you can just download them first in an Excel format and reuse them as you see fit. Then we're also developing a queryable database, which is queryable by an API, and also an embeddable map component, which will look like Google Maps, for example, that you can include in any website with very limited integration effort. So all of these tools will be available free of charge and, of course, under an open license. The data set we also plan to be accessible through the EU Open Data Portal. And finally, we're also developing a demonstrator website, which will make use of the merged data set that our partner websites provide and make it available in a user-friendly way. This website is not meant to replace all the other websites that are already available that I showed as examples earlier. Rather, it aims to show the value of using the data from these websites in order to provide a value added to their users and also additional users. So with this website, we'll be targeting rather future partner websites rather than end users. We just want to show, for example, a cluster organization in Germany that if they use the data from our website, they can give more value to their SMEs. The website will also be freely accessible. And finally, just one slide about our partners. So we already have partnered up with a number of commission projects that already provide data to our website. And we have also other project stakeholders that are very much interested in providing their data, and hopefully in the future they will also provide their data sets and share and reuse our collected data sets with each other. And I really hoped that I can really show you the operational website today, but our development team and the commission IT unit will need a couple of more weeks to ensure that everything works fine. So till then, if you're interested and would like to learn more about the project and the data sets and what we can provide to you, please reach out to this Grow SMESA functional email box on first line, or to me directly. And I would be very happy to give you more information about the project. And if you have something to share with us, then it's even better. So I'm now open for any questions and answers.
Thank you very much, Szabolcs. Thanks a lot for these explanations and for making yourself available for future questions. I don't have any for the moment, but we still have to listen to Robert, and maybe we will have a couple of questions at the very end, which might be addressed to both of you. We will see how our participants contribute to the chat feed. So now it's a pleasure to turn to Robert Rovetto. Robert is an independent ontologist, and as I said, he will be talking to us about semantic reference for space flights. Robert, are you there? I can see your screen.
Hello, can you hear me?
Yes, hello, yes, we can hear you. And if you can put your screen in, or your presentation in full screen mode, please.
Yes. Should be, does that work?
Good, yes, thank you.
Okay. So yes, thank you for organizing this, and to the audience for their time. So today I'll be speaking about semantic reference models for spaceflight. So as a summary for the presentation, I'll be briefly just introducing myself, talking about the target domains and techniques, including knowledge and semantic modeling and artificial intelligence, then about the specific project effort, followed by a call to action for that. So a little bit about myself. I'm an ontologist, conceptual modeler, philosopher, focused on terminology, as well as ethics in ontology and semantic technology. Since 2011, I've had about 21 articles. Most of that are on the topic I'm talking about today. I'm an aspiring student. I'm actively searching and applying for continuing studies. My master's degree, the graduate degree, was in philosophy with a focus on ontology, interdisciplinary, and below are a couple of websites that are relevant. On the right side are some of my service to discipline. I have extensive volunteership currently and over the years in different associations in both space flights as well as the international semantic community. And in my spare time, I serve in, or I try to serve in volunteer maritime rescue activities. So today, the target domain and the techniques are going to be the discipline of astronautics or spaceflight. And that encompasses a number of sources of data. So for example, surveillance of the orbital environment, telemetry data of the spacecraft itself, as well as navigational and orbital data, observational data, which includes some of that, various sensor modalities, various sources of sensor data, and provenance data, which I think the community should be knowledgeable with. And so the target techniques are basically knowledge-based or ontology-based approaches. And that includes knowledge representation and reasoning, ontology development, MBSE, natural language processing, and so forth. And for this particular topic, I call it spaceflight semantics, among other terms. So knowledge modeling in AI, as everyone is probably aware, involves various aspects from computer vision to pattern recognition and NLP and knowledge bases. My focus is on knowledge representation and reasoning, which is basically how to represent knowledge, beliefs, or statements in a meaning in a manner that computers can act on. And this may involve the use of ontologies or things called semantic nets and taxonomies, and it's related and applicable to MBSE. And the idea is to make data self-describing, with a common thread being meaning, the capture of meaning and modeling itself. So the project itself is basically modeling the space domain, broadly construed, but focused on spaceflight. And I have an in-progress set of semantic reference models or ontologies about various aspects of that target discipline. And the idea is to provide metadata, vocabularies, ontologies that capture both qualitative and quantitative aspects, with the preliminary focus on the qualitative, and representing things such as the objects in orbit, occurrences in orbit, various systems, space situational awareness, and so forth. Other goals are to tag sources of data with the metadata elements in those products, and to provide a shared meaning across data sources in the discipline, as well as to support artificial intelligence applications where they may exist. And the principles I aim to have for this project are neutrality, being systematic, being accurate to the target domain, flexible and widely applicable. And this is a set of example set of ontologies that I'm working on. For example, some are focused on orbital debris objects. Some are focused on different categories of spacecraft, others on space mission design, or events that occur in orbit, as well as more interdisciplinary things such as policy and law. And the idea is to create sort of a modular set of these domain ontologies to form a unified framework. And this is a screenshot of some of the ontological content visualized. An example application is a visualization that used one of my ontologies, which with my colleague, we have a technical memorandum on describing the process where R and JSON-LD was used, as well as some semantic editors. Other examples are the articles above on the top of the screen. My first article was in 2015, and more recently in 2019 and 2020 with a couple of co-authors. And in summary, the goal is to create a unified but modular and reusable set of ontologies or knowledge graphs for spaceflight and the space environment. And so the idea is to create vocabularies, metadata sets, semantic models, ontologies, various semantic resources on the spectrum of semantic technology. And it is a work in progress. And on that note, as a call to action, since 2011, I've been actually actively seeking opportunity for this. None has been forthcoming. So if there's anyone in the audience that are open to a PhD student or have an opportunity to formally collaborate or support this, it's all been in my own time. And so I would like to finally make this a sustainable and supported activity with mentors and other persons to realize. So thank you so much to Endorse and to the audience. Please feel free to contact me, and yes, thank you so much.
Thank you, Robert. I have received a couple of questions, one for each of you, and actually, since you're online already, I will start with you, Robert. It seems that the data visually represented is is part of the content of the portal. So do you plan to use a specific tool for visual data? And what is it? And is that tool providing new possibilities?
So as I understand, the question is about whether I'm going to use a particular tool to visualize the knowledge models. Is that correct?
That's what I understand from it as well, yes.
Okay. Well, first, thank you for the question. I don't have a particular preference for the tools. That is part of what I hope to explore in greater detail if an opportunity is forthcoming, either as a student or other formal support. But I have explored in some of my research various tools. So none of them are preferred necessarily. So it's an open question.
Thank you. I'd like to come back to Szabolcs. Szabolcs, are you there?
Yes, hello.
Yes, hello. Yeah, I received a question that's more for you, I believe. Somebody who'd like to ask you how you manage the changes in the interconnected data, how you detect broken mappings and so on, and how do you restore them?
Yes, so we have developed the data model, agreed with the with our partners that joined from the very beginning of this project, and then we are developing a set of APIs on one hand to support the querying of the central database, and the other hand to upload on the other hand to support the upload of data from the partner sites. So we foresee periodic updates coming from the partner sites to our central database via APIs, and so far these are just in development, and the APIs use the data model that has been agreed among the partner websites. And to detect the broken mappings, so these websites, they already collect information on their innovation supporting actors, such as technology centers or digital innovation hubs, and they are responsible in managing any kind of broken URLs or mappings. And what we do as a first step in the project is we combine these data sets. However, we do not yet create mappings between these various data sets as of this moment. So, for example, it happens that one initiative collects advanced technology centers, and another one collects information on digital innovation hubs. And it can happen that one organization is both a digital innovation hub and an advanced technology center at the same time. And the poor organization has to send information about themselves to two European projects at the same time. So far, we are just collecting this information, and we do not try to make these interlinks between these entities. This will happen in the next step of the project later on.
Okay. Well, thank you very much. Thank you very much to both of you. And I know that we will continue to discuss innovation as part of our afternoon. May I remind you, all of you in the audience, that we still have our Slido survey open at #Endorse 2021. So please have a look, answer the questions of the Slido survey. And now the time has come to turn to our next speaker, and I'd like to invite John McRae from the National University Ireland in Galway. Good afternoon, John, and welcome. I don't see you.
Hi, good afternoon.
Good afternoon. Yes, hello. Yes, now I see you. And thanks for joining us. We're going to talk with you about ready-to-use linguistic data. So I'm very curious to hear what that sounds like. Over to you.
Do you see my screen?
We do.
Okay, great. Yeah, so welcome everyone. So I want to talk to you about a project that we've been doing that's been funded as part of the Horizon 2020 ICT course. So this is a project called Prêt-à-LLOD. It's about making linguistic data ready to use. So I'm Dr. McRae. I work at the Data Science Institute of National University of Ireland, Galway. So we're on the west coast of Ireland, on the Atlantic. Very beautiful out here, and I hope in better times you'd all be able to come and visit. So this project had a few objectives. The first one was about kind of really to do with cross-sectoral data access. So there's a lot of data available, and particularly when we're looking throughout Europe, there's many languages spoken, official EU languages, and many other minority languages. And so trying to build, natural language processing, text analytics apps that can work across the entire digital single market is a big challenge. Another challenge is even if you can find the data, that there's often issues of licensing. There's often the copyright aspects. So being able to also find the data you need, but also to be able to deduce if you can legally use that is a big challenge. So that was really our kind of first goal, was to look at how we can help in data access, particularly multilingual data access. So the second thing is really trying to look at how we can make language technology interoperable. So we come from the perspective of linked open data, done a lot of work in terms of making data sets that connect to one another, that share identifiers and that work together. And of course, this has led to the development of the linked open data cloud. So this diagram that you've possibly already seen a few times. But we're also looking at newer technologies that are really, we think quite impactful in here. So, for example, things like Docker, which allow us to, to package up software and to share it, and then technologies like JSON-LD. And a big part of this is really connecting up with some of the initiatives that are going on in Europe, particularly things like the European Language Grid, which is, building a new infrastructure for language technologies across Europe. So really trying to make sure that we can make all of these language technologies work together, so that you can just pick it off the shelf and then use it, and it'll work straight away. And finally, I kind of our third objective was about sustainability. So by sustainability here, we mean sort of long-term access, rather than necessarily looking at the carbon footprint of natural language processing. But we're talking basically about how we can make sure that the data sets and the services that we build in this data set are still functioning in 10, 20, 50 years' time. And so this is, this involves a lot of things. First of all, we need very good metadata. Licensing comes up again here, trying to make sure that we can license data, how we can ensure that data is successfully archived into the long term. And a particular aspect here that's very important is, of course, with smaller languages, minority languages, where there's very little data. So the data that does get created is particularly important. And we've kind of approached this through a dual paradigm, both services and data as services. So, the idea of data as services is that we have data and you can access it through web services, and you can, in this way we have interoperability. But we also do the opposite thing, and we take services and we wrap them up into Docker containers. And in this way they become data. So, we can also share data as it's deployed as single files. So services as single files that we can, then use all of the data things like metadata and licensing to describe. So those are the main three objectives. And we kind of understand this as kind of a data value chain, so that we're taking data, we're taking our raw data like language resources developed by linguists, other kinds of open data, maybe specific documents. And then we develop some specific tools to help in this data chain. So we have transformation tools to try to convert this into linked open data, to link it together, to use a single format. We have a linking tool that then helps to build all these data sets so that we have interoperability. Then we can create these services out of it. And from those services, we can connect them together into workflows, which solve, real world problems. And we have a workflow engine here. And then we've evaluated this in the context of four pilots with commercial partners. So in terms of the tools, we have sort of these 5 main tools that we are developing in the project to try to solve these aspects of the data value chain. First of all, we have this discovery aspect, so how you find these data sets. And we've developed a website called LingHub, which we're now updating, which contains a large amount of information aggregated from many, many sources about where we have data sets for natural language processing and for text analytics. We're developing a new transformation tool that will be called Finton, that makes it really easy to take any kind of CSV or XML file and then turn it into RDF and give it semantics and give it meanings. We then have a special data manager, which actually stores information about licenses on the blockchain and allows you to associate and to verify the compatibility of the licenses of multiple data sets. We developed a tool called NASH. NASH is this Irish word for links, which is a tool for helping you to link together data sets with a bit of a human-in-the-loop way. And finally, we're developing a new workflow engine called Changa. Changa is, again, an Irish word. It means language, which allows you to build NLP tools for your particular task. So all of this is available on GitHub, and you can see our work there at github.com/Prêt-à-LLOD. And finally, I'll just talk a little bit about the pilot. So we had 4 commercial partners in the project. So they're working on various interesting applications of the work. So we have the Semantic Web company looking at knowledge graphs for management across sectors, so particularly doing multilingual terminology and building on their successful pool party app. We have Oxford University Press, who makes the Oxford Dictionaries for English. So this is really looking at applications in lexicography and how we can use data linking tools to support the kind of rapid development of dictionaries and extensions. And, language never changes, so dictionaries always need to be improved and new words added. So how can we use, linked data and modern language technology to improve this? Dairy Links are a company, actually a startup from NUI originally, that focuses on open government data. And they're really looking at how you can use language technology to make open government data available in other languages. So particularly for immigrants to a country, how do we show data in a way that would help, say, a Spanish immigrant to Ireland? And finally, Semalytics is a new startup, and they're really looking into the applications in the pharma sector and how we can do text analytics to understand the patient and build, models that really can take in real-world evidence and use this to understand what's going on in patients and make recommendations to pharmaceutical companies and to drug makers. Okay, so that's a brief overview of the project in 10 minutes, and I'm open for any questions on this.
Thank you very much. Thank you, John. And yes, I understand that we get some questions from Slido as well. So I would like to invite our participants, our audience, to also use Slido if you'd rather, for whatever reason, not use the chat function of our platform. So Slido, Endorse, hashtag Endorse 2021. For questions, now I have already received one for you, John. What are the special characteristics of the multilingual knowledge graphs that you use?
So, we work with all kinds of knowledge graphs, looking at across many languages. So particular partners are interested in different kinds of knowledge graphs. So a big thing is looking at lexical knowledge, so kind of dictionary-like knowledge. And of course, we've developed this through the World Wide Web Consortium. We've been developing the Ontology Lemon model, which is now very widely used as a model for representing dictionary-like information on the web. And something we're looking at as well, but other partners, like, for example, Dairy Links, looking at government data. They're looking at multilingual government knowledge graphs, and that's a very different kind of data. So we're targeting tools that can be flexible across many domains. And
thank you. I'm just checking that I have not received any further question. I think anyway, if anybody wants to raise any further point with you, they will be able to find you to continue that conversation offline or online, but not through the conference. Thanks very much, John. Thank you for this presentation. And I would like now to invite Stine to join us. Stine Jensen is from Dalexi in Copenhagen, and she will be joining us to talk about the uniting power of terminology. Hello, Stine. Good afternoon.
Hello.
Hello. So we have your screen. Yes.
I hope so.
Yes, so if you put it in full view, and then we'll be all set.
Thank you. I was listening, paying so much attention, and now I'm on. Okay.
No
I just
worry,
wanted
no
to
worry.
take a few seconds, like all the other speakers, probably to thank the whole team behind the Endorse conference. I think I know that during these pandemic times, you can't say anything positive about the situation, but this is one of the positive things, I think, that you can unite so many people from different places and simultaneously. It's quite impressive. Also, thank you to the other speakers. I've been following as much as I could, and it's been really interesting. So I'm a little bit out of my element here, so please bear with me. I actually am a terminologist and intercultural mediator. I have a background in translation, and particularly in the EU translation. But as Florence said, I am calling you from Copenhagen, where I founded Alexi. So I come here to talk about the ISA framework as an opportunity to unite us in terminology. And I do that because I have been completely obsessed with collaborative terminology management ever since I was working on the establishment of the Danish Terminology Network, which you might know. I'm going to skip further introduction because we are short on time. So please connect afterwards and I'll be happy to continue. So what I would like to do actually is to go a bit back to basics, because it is in my experience that as particularly in online conferences, as we come from so many different backgrounds, that it's never bad for anyone to go a bit back and define what we're talking about. So of course, terminology is many things. I'm now going to talk about the interconnection and the relationship between terminology and knowledge management. Terminology is, of course, a study and research work, terminology work. But to make it really simple and easy to understand, I like to talk about it as the vocabulary of professional language, covering a given knowledge field. So this means that you can't just take terminology and from all kind of different knowledge fields and mix them all together. I know that many times you find this when you search, for example, open source resources on the internet, or you might not be able to read the knowledge fields well and knowing which particular domain that they belong to. But best practice is not to mix everything in the same database or word list or glossary or whatever. The purpose of terminology is to facilitate communication, basically, and make sure that there are no understandings. That is why we define concepts. It's concept oriented. So it's actually the contrary of dictionaries. And also terminology is not black and white. There are a lot of gray zones, as there also is in, the field in knowledge in general. If you think of terminology, as I said, as profession, specialization, areas, fields, then you will also see that different or the same terms are shared. The terminology can be shared between different fields. For example, like well-being. The term well-being is in pedagogic, psychology, medicine, and so on. So we need to classify, and I brought some examples today of a classification system that is used. I brought examples of YATE, the European, the terminological database for European terminology, which is mainly used in-house, even though it's open source. It has a broader audience as well, but it's mainly used in-house for the EU translation. And then there is also the Euro Term Bank, which is less traditional than YATE. It is more like a word list and glossaries, and it's composed of different collections from a lot of different terminology resources, both from member states. It also contains YATE and also private sector collections. So it works a lot with these collections. And then I brought you the portal of the EU legislation, EURLEX, which all of which uses EURVOC as a classification system. So EURVOC is EU's multilingual and multidisciplinary thesaurus. Did you lose the presentation? I'm going to try again. I hope that you're still with me because I lost the presentation. I hope it didn't happen to you. If not, please let me know. And it operates within different domains. And it's important to know that actually terminology is not always a multilingual phenomenon. It's very much monolingual as well. But as we operate within this European setting, well, there is this special way of working with 24 different originals. So you many times find this multilingual aspects. So here is Jade, a screenshot of it. I didn't want to risk not being able to go online well from here, from the presentation. And in here you can see it operates on 3 different levels, language dependent, and term level. And you can see a lot of metadata, which is repeated in all different term entries, and also the domain, which might be more interesting for us right now, which in this case, automation and is information technology. The cross references, so the gray zones, the overlaps, are in Jade manually put. And here, unfortunately, I don't have one, of course, but you will normally see them with the Jade ID reference, and ideally that you can click on it and go to whatever is related. To make this a little bit easier to manage than go on each entry, Jade also works with collections, which you can download from also the public version of Jade. Here we have the Euroterm Bank, and as I said, I have tried to make circles this time around what you get as a result. So you can search by language and domain, and this again, EuroVoc coming into place. And then we have metadata like languages, and you see them as a list. You can click on the bottom of the screen. I couldn't get the whole one. You click on the collection, and it takes you to the next screenshot, which is in this case Microsoft Terminology Collection. So even though the Euroterm Bank is working mostly within the public sector, it also has private sector involvement at some point. And the last one here is Yolex, and this is not directly related to terminology, but it's very much a very reliable source for EU terminology, at least. You will see it referenced many, many times in the other 2 databases. I think that it makes the connection obvious. So it also uses EuroVoc, and you can browse content by domain. So it is exactly the same system, but you can say that it depends. I mean, EU terminology uses this as a reliable reference, in particular the official journal of the European Union, but EU legislation is also very much dependent on EU terminology for drafters and so on. I hope I'm okay on time. But here we have the another tendency that I just quickly slipped into the presentation, which I wanted to show you because I got a little bit inspired by this smart files network that I was lucky to hear about. And this is a new tendency also that might make the relationship a little bit more obvious between knowledge and terminology. And you can see here that concept mapping is being integrated. This is the example of Perl, which is probably the most known one within the terminology world, at least. And you can search by linguistic search and concept map search. And I think the most beautiful thing here is that you get this overview. We all know concept maps from school, brainstorming, where you can see relations between different things, and it's exactly the same. So this is by domain, and you can create your own concept map. It's quite, yes, it's also adapted to some other tools. So to the point, why am I here? I'm here because I think that ISA, the framework of ISA, and presents an extraordinary opportunity to perform large-scale terminology management, as all the field work has already been done. A lot of consolidation, a lot of alignment, a lot of network and involvement of terminology users, creators, subject matter experts, etc., has already been done. So why not use that and work on that, also based on the terminology that's already been done? So I want to propose a more than an EU scope. I want to propose private sector engagement to create one source of reference where you would go even further than what we saw with the Euro Term Bank and actually be able to consult the original sources directly from the database and make this lookup function. I think private sector engagement is extremely important when you talk terminology, because the private and the public sector, they are interconnected. You cannot, for many sectors, you cannot say they only exist within the EU. And such a resource would also serve for EU member states without any terminology, public terminology management, such as my own, Denmark, for example, and be a reference. It also opens up to draw on the experience from the EU and maybe include the great expertise of the central coordination of European terminology. So for this to work, you need to communicate, and you need to be very, very, very insisting on this so that everybody knows what is going on. And this would also benefit the whole ISA project itself. I can call it a project. It's quite big. And a way to do it is probably to focus on something which is not terminology. So you focus on artificial intelligence. Why do we want? Why is terminology management necessary? Why do we need to do a job that's already been done? Might be the argument against. Well, we won't redo it. We will work on it. The connection between knowledge, data management, readability. We want to prepare terminology for when the technology is ready to integrate it. One of the big questions within the translation has been, how do we make machine translation choose the right terminology? And as it is right now, we cannot. Now I went too fast, maybe. I've put some references for you. Thank you so much for your attention. And if you have any questions, please ask.
Thank you very much, Stina. No, you're right on time to give us the opportunity to share at least one question with you, which I have here. The ISA2 program covers much more than terminology. It is about digital solutions that enable public administrations, businesses, and citizens in Europe to benefit from interoperable cross-border and cross-sector public services. Is there a special sub-project for terminology management under ISA2?
Well, luckily the people are here. I am mostly aware of the efforts being done in the PMKI context. This was how I first got in touch with the ISA. But I think that indirectly it is integrated, if I'm not mistaken. But particularly for terminology, no. Taking it into consideration, yes.
Okay.
If I'm wrong, please correct me fast.
Well, I'm sure if somebody has a comment to add, it will come up quickly in the chat. I don't see anything coming up right now. And you mentioned PMKI, for which we are going to have a demonstration later on this afternoon in the final session of this track. So if anybody is interested in particular in this program, make sure to stay tuned until the end. I'm just checking the chat. No, it doesn't look like we have either a question or a rectification to what you have just said. So it must have been correct. So thanks very much, Stina. Thanks for joining us this afternoon and for making this presentation. Thank you. So I'd now like to invite our next speaker, and I'm happy to welcome Ivo Velichko from Quistgaard in Belgium. Ivo, are you there? Yes, I can see you. Good afternoon. Ivo is going to be talking about linked data, and we see your screen, so I think you're all set. Can you start sharing your screen?
I just started.
Yes, very good. Thank you.
It's working. That's fantastic. Thank you. So Endorse is a conference on reference data and semantics, and they're mostly about improving interoperability through reuse. That's why to walk the talk, I reused Endorse in my title. I've been working with EU institutions around linked data in different capacities, designing and delivering training courses, providing advisory services, developing prototypes, guiding linked data projects, and along all that, building a linked data community of practice. This work, as well as the preceding work that I did on enterprise architecture and IT governance, convinced me of the huge untapped potential of linked data. And I don't mean linked open data only, but also linked enterprise data, because there are billions of IT investments spent to solve problems that are practically dissolved when using linked data. This is confirmed by a number of signatories of the recent movement for data centricity. But regardless of the potential, linked data is still marginal even today, when knowledge graphs became so trendy. Linked data, it brings universal approach for naming, meaning, and shaping of information. It was meant to be the second big information revolution after the World Wide Web. It was supposed to complement the web of documents with the web of data so that humans and machines can use the internet as if it's a single database, while enjoying the benefits of decentralization. And when you think of it, that's a beautiful balance. That's the balance between autonomy and cohesion, which is important for the survival of any system. As you know, it all started with this email by Tim Berners-Lee in 2006. What is the situation now, 15 years later? The number of linked open data sets grew significantly. We have 1,492 data sets, and that is a lot. But is it? What part is this of all online data sets? It's much less than 1%. It's much less than 0.005%, in fact. One may think if this is the case, maybe people have a better way to manage data. Maybe they don't need linked data. Well, now in the Corona lockdown, many people needed to buy new monitors. Say you want to ask for all the prices of all 4K monitors below 600. What you'll get is not only wrong answers in the view, but actually most of the online shops will not be represented at all, especially small and medium businesses, which is not only bad information management, it's also not ethical. So now in 2021, we still don't have the worldwide data search. It's not possible. And we could have that with linked data. Inside enterprise, the situation is not any better. Billions are wasted every year due to decisions driven by the application-centric mindset. And I guess by now you're quite fed up with the silo metaphor, so let me try another one. Imagine a world where one can only read what one have written and nothing else. Oh, well, in such a world, people like Agatha Christie, for example, would have been lucky to read 73 or 80 books, but most of the people would have read none. And I think you all agree that this is an absurd world. And yet, We invest billions in our enterprise information landscape to create exactly such a world where most applications read only the data that they have written. We create corporate applications that are big silos, where application and data are tightly coupled, where we have hyperlocal identifiers. It's sometimes funny to see people present digital twins, but they're more like analog dolls, not realizing the importance of having URIs for all enterprise entities and relations. And of course, the majority of data models are buried in the physical implementation layer, separate for each information system. What is the result of that? The result of that is high cost of change and high cost of interoperability. And maybe corporations and private sector, they can afford that, but I don't think public sector can continue doing that. That's a waste of public, of taxpayer money. We do not have only big silos, we have also small silos like spreadsheets. They are like plastic bags, they're convenient and multifunctional, yet they pollute the information environment. And I repeat, they're convenient, I also use them. But yeah, you can check out this article, The Tyranny of Convenience, a few years ago in New York Times. And that can also be solved well by linked enterprise data. Linked data is also it's blessed by being with a special position. But it seems that it's still marginal. So that's the first question. Why is linked data still marginal? What can we do to change that? Maybe we need to be patient. The first modern passenger flight happened by Boeing 247 in 1933. That's 30 years after the first flight. So you may think you need 30 years to wait until something which was available as technology to become mainstream. You'll say, well, that was the case before. Now that's not anymore because things accelerated. Well, not really. In 1969, the internet was invented, and then it took 30 years to become mainstream. So if we decide to take this and extrapolate it, then maybe we will have linked data in 2047. If we count that Shackle and the RDF star, the two last important, maybe not last, but really important puzzles of the technology stack, semantic technologies, that they appeared in 2017. So we need 30 more years, and then there is nothing to worry about. But in fact, there is. Historically, what happened is RDF, it appeared in 1999, while LPGs in 2009. And yet, for a much shorter time, they took bigger market share, not only in terms of how much data is available as property graphs, but also the way the ecosystem is currently developed. You would find much smaller number of stores for RDF than the variety of offerings that are for property graphs. Linked data itself is blessed to be in a position between philosophy, science, and industry. And philosophy don't mean only because ontologies, but also because of, you think like object is related to resource, the philosophical question of property name and how it is technologically solved by URIs, and of course, ontologies is something quite known. In science as well, it's a well-established research area, semantic web. But this blessing is also a curse, because it so happens now that for business people, it seems that linked data is too IT, and for IT, it's too academic. And it seems that it failed to create a sustainable ecosystem, an ecosystem where you could have vendors and users and developers live in harmony and thrive. Vendors specifically, they were not attracted, probably because it's not easy to make profit using open standards. But this is changing. I know it's controversial, yet Google made a lot of boost with JSON-LD and RDFA to be supported as standards for encoding linked data in HTML. And recently, although previously only small companies they were involved in that, recently we have big giants entering this ecosystem. Amazon appeared with Neptune that offers RDF service. For developers, they're really drowned in options. It's quite difficult for them, especially for the average web developer. There is no attractive tooling, way too complex for them. The technology stack is mainly on the back end. There's almost nothing on the front end. That is also changing, but slowly. Apart from JSON-LD, we have things like quite a few now offerings like JavaScript RDF libraries, Python libraries, and tools like LDFlex that provides accessible linked data patterns for developers for most of the cases. For users, they're quite neglected. They are required to have technical skills because for most applications, they would require Sparkle knowledge. There is not much to be done with natural language query. That is also starting to change. Now there are ways to translate natural language questions into Sparkle, and QAnswer and Freya are two such examples. But we can also see this problem where you wouldn't expect it to be, and that is in the linked open data, with the linked open data publishers. They publish linked data for others to use, but rarely use it themselves. That's why they perceive linked data mainly as a cost, mainly something not really that they have skin in the game, being dependent on it for their daily job. So there is a lot of linked open data, but not much linked enterprise data by the same publishers. And also there is another strange disbalance. A lot of effort are put to publish metadata and not enough on data. It is as if what is offered is like you enter a wine shop in which you can watch the labels, but you cannot try or drink wine. So I asked around to see if it's what others think about it, and I made a survey that I addressed to people that have a lot of experience with linked data. In fact, from the respondents, most of them, they had over 8 years of experience. And number one is maybe unsurprisingly too academic. I probably would have put something else, but that was what was confirmed. Then next is little care about end users, failed to attract IT vendors, and too complex web developers. And that suspicion that things are also problematic with linked open data publishers, it was confirmed by quite a number of respondents. Of course, you can also participate if now these results would not influence too much what you. So have you say this is the link, you can, the survey is still open. But these were the 5 things that I supposed were the problems. Of course, I was interested to know others that I have missed that people find equally or even more important. And something interesting happened. After I analyzed all the answers, it seems that with the large majority, most were about the tooling that wasn't available. I was quite surprised to find that because I was so much used to not having convenient tooling around in data that I never thought it could be otherwise. The next one was around skill set, and the third place was it was too complex. Of course, there were other things that were sort of outside these main clusters, like resolve challenges on authorization entitlement, not enough focus on person-centered graphs, and something I quite subscribe to: IT project holders manage their projects through KPIs, but knowledge management is a transverse discipline and can't be seen as a single project. Indeed, what kills many programs for linked data are projects. And there was one answer. So this was around the average tooling skill set. And there was one answer that was an outlier, and I think we should pay a lot of attention to outliers. It was outlier not only with the quality of the answer, but also with the amount of things that were said. I will not ask you to read that, but just a few very important points. People don't care about sharing data in proper ways. They don't see the need to integrate data if the main benefit of doing it are more for third parties than for themselves. There are even cases where centralization for a company is actually the attempt to dominate the market, and the example given was Google. Another thing was that RDF star came too late, where property graphs were quite dominant at that time. So why don't we, the way we do with open data, we do not treat the same way if people publish PDF, CSV, or RDF. They have different value. It's realized we have this 5-star deployment scheme for open data. Maybe we need similar ways to distinguish the different value of different ways to manage linked data and to make it available. And that should be not only for linked open data, but also for linked enterprise data. And if people have a way to attract users, if they build stellar applications, if they make it easy and accessible for developers, if they put a lot of data, not just metadata, then apart from the ground level, which is the top level of open data, linked open data, we could start rating different applications in a different way. But even if we don't do that, what is important to start doing to change the whole situation? Well, my suggestions are the following. First, attract developers. Make it easy for them to use and create linked data. And Wikidata is one example of that. So when you have a Sparkle query there and you don't even know Sparkle, you can wrap it in JavaScript, Java, Python, and R just right away. It's automated for you. Google, again, did a lot of good job, because now the recent Common Crawl Corpus discovered huge growth of the available structured data as linked data in the HTML. Then ask in other tongues. Of course, standards are important. Of course, Sparkle is great. But see, for example, TopRate started, allowed in their tooling, also other vendors, to query not only with Sparkle, with GraphQL. That is much more natural for a lot of front-end developers. And then another company, RDF Ox, they offer management of the graph not only with Sparkle, but also with Datalog. So they use Sparkle for querying and Datalog for reasoning. So ask in other tongues as long as they are standards that they're open and available. That's not the case for property graphs yet. Be inclusive, make data accessible for all kinds of humans. Kohesio project was presented, and now I hear that they started experimenting with querying with natural language questions that are translated into Sparkle, and then you can train the way this is performing. And then, last but not least, build an awesome app. Create value, set an example, inspire. It is not enough. It is not enough only to publish linked open data and to invite people to use it in different ways. You should set an example. Now, remember, Tim Berners-Lee, apart from getting together HTML and HTTP to bring the World Wide Web, he also wrote the browser. And an example of public sector for that is the route compatibility check prototype of the European Agency of Railways that was presented a couple of days ago in this conference by Julian Rojas. And I would like to end with the message to linked open data publishers. If you want people to use your linked data, start using linked data yourself, walk the talk. This might sound counterintuitive, but to be really successful with linked open data, you need to work towards linked enterprise data. So either initiate or support the current efforts to build an enterprise knowledge graph of your enterprise data stores. How are we doing with time?
We're doing fine. I was going to say I don't hear you anymore, so I suppose that you are done with your presentation, but we have some 10 minutes with question and answers time, which is great. So yeah, to all our audience out there, please send your questions either via the chat function on our platform or also via Slido, hashtag Endorse 2021, and we will make sure to convey them to Ivo. Ivo, I have here 2 questions actually already. Why do you think that JSON LD has been more popular than RDFA in Google? Do you want the second one now maybe as well, so that you can, continue? And then, or no, as you want.
Yeah, just give a second one. Yeah, of course.
Yeah. Linked data provides an appealing call from an interoperability perspective. As any trend, it has its ups and downs, risks and advantages. What could be the thing to avoid when deploying linked data in institutions?
Yeah, so for the first question, I don't actually remember what was the result of the latest Common Core corpus, how much linked JSON LD was discovered, how much RDFA, and how much microdata. For sure, microdata was the most. I can share the link to that statistics in the chat. Mm-hmm. So I don't know if JSON LD or RDFA is more that it's available. What I tried to convey is that the efforts of Google to standardize that, although many are not happy with the way they do it, in the way they're trying to dominate the market, actually made a big boost to the usage of linked data, although that's a surface linked data, only in the HTML, not something more than that. But that's already brings a lot of potential, and it could help towards solving the missing worldwide data search that neither Google nor Bing nor DuckDuckGo or other search engines currently provide. The second question is a very good question. I wish I knew the answer. I really don't. One thing that maybe it's a big risk is to go for a big bang approach. You should really start slowly and allow as much as possible hybrid solutions until both the way your organization can make a digital transformation through a data-centric approach is confirmed and supported by your maturity to enable it. it's not really easy to unlearn certain habits, not only technological, but the way decisions are made previously. And let's face it, in many cases, linked data would be risky, just because the established ways are there, and there is much more experience with them, of course. But it's worth taking the risk.
Very good. Well, I'm sure that's food for thought for those amongst our participants who are considering implementing linked data solutions. So thank you very much. I don't see any other question from my thread here. I don't see any on the chat either. So I think that we can let you get off the hook. Thank you very much, Ivo. And ladies and gentlemen, we have the opportunity now for a little break. Instead of 5 minutes, we have 10 minutes ahead of us. So see you back here at 4:25 for the final stretch of our innovation track this afternoon. See you in 10 minutes. Thank you. Bye-bye. Dedicated to innovation. And innovation is definitely going to be the core topic of our next presentations. And it's my pleasure to welcome our speaker for this coming slot. Welcome to Sergej Kozlovic. Sergej is from the Institute of Mathematics and Computer Science of the University of Latvia. Sergej, good afternoon.
Good afternoon, thank you.
Hello and welcome. And if you can share your screen with us, I can leave the floor to you.
Okay. Okay,
sorry, yes, now it's coming in full view. Sorry, it wasn't there yet. Thank you.
Okay, so actually this long title reduces to this short telegram. I would argue that open data are not enough. We need also open web services or executable code. Second, I will argue that we need some kind of operating system for web services. And finally, I will explain how we can tackle heterogeneity using semantic web technologies. And I would like to start with a story. Perhaps you are familiar with this Professor Peterson. And once upon a time, he almost lost access to all his emails, calendar, and YouTube account because Google blocked his account. Fortunately, he is very famous and he tweeted about that, and some colleagues at Google could recover his account. But are you that famous? Even if you are not so famous, or if you are famous actually, Twitter perhaps cannot help. Even if you are, for example, President Trump, they even in this case can block your account. And your Google account is not just about Google. Actually, perhaps you use it for signing into other services like Spotify or whatever you name it. And actually, I saw this page from Google myself when somebody on my network had some virus who connected to Google, and Google blocked access to all those services to all my network. And there is one more problem. If you marry some not open service like Google Photos or WhatsApp, they can change their policies or pricing, and you have to stick to their conditions. So the first telegram is that we need open web services. And by open web services, I mean that they can be open source services, so we can take it and run on our own server, but somebody else could run that service for us. So it may be freely accessible service, or they can be some paid service, but it has to be easily discoverable and accessible via open standards. And why I consider that some open services can be paid. This is an example of OpenStreetMap data, and all these data actually are open data, but when you use some tile services or geocoding, you have to deal with terabytes of data, and actually these services are usually not free. So it's okay to pay for those services, but they have to be discoverable, and we don't wish to deal with all those payments or tokens and all that stuff that is associated with all that payments. We need some easily accessible way to connect to those services. And this is one example why it may be difficult to provide such services. Even if you have to configure just an email server, you have to perform all these steps. And I tried to do that, and it's not so easy, actually. So this is an obstacle. If you wish to provide some open service, you have to deal with all that configuration issues. Next, you have to deal with maintenance issues, because some services that you rely upon may change their APIs, and you have to deal with broken links, with the heartbleed problem which can occur, and you have to update your server software and so on. And finally, the next obstacle is heterogeneity, because there are many standards and you have to deal with all of them if you wish your service to be usable. Next, you have to deal with the user management and so on and so on. It's too complex because we have to think about so many issues that our brain is designed to tackle with just one problem at a time. And what we do if we speak about traditional software, not just open services, but like traditional applications. Actually, all these complexities are tackled by the traditional operating system. It manages resources, it tackles with heterogeneity by using drivers. For instance, you don't think about which type of media you use, like a hard drive or optical drive or USB stick. The operating system factors out these issues and also these security issues, and you can just think at the level of the API of that operating system. And this is my next point. We need a similar operating system for web services, and particularly for open web services. And to provide such services, we can write them against such virtual web computer. So we can use the same API as we use for traditional operating system, and we can access web memory, which is synchronized between all the involved servers or nodes. This web computer can invoke code that can run on every network node that is connected to that web service, or even we can use some input-output devices which can be scattered around the network. And actually, this web computer can be implemented in the cloud or by your own services, it's up to you. But this web operating system can tackle all these issues and factor them out. And actually, my point is that there exists such web-based operating system. I am the main author of this web app OS, and it is licensed under the European Union public license. So it's open source. You can take it, you can try it. And this is how it looks like. And maybe I can show some demos. Now I can switch video to these demos. Okay. So this is how you log in, and you can take this desktop experience here, and you can run applications. And here, for example, I try to run the Allgrad editor, which is an ontology editor running in the web. And actually, there are other interesting aspects about this. For instance, we can connect from the outside, and here I created a box, you see, from the other window, and actually this can be another server that can access web memory running on the left server and manage those data and even invoke code on that. Oh, sorry, something went wrong. But okay, I guess that you got the point that web services could be invoked and use that shared data and invoke shared code. Okay, now I will go full screen. And here is the internals of that operating system, but you don't have to know about that because it's very complex, and actually it just works. But the question is, can we go even further? And yes, we can add semantic web standards to this web app OS. And the main point is that we allow to publish data using different formats. And we describe them using RDF, and this web app OS can access these heterogeneous data using drivers, like operating system accesses different media. And for the code, we can use the similar approach. We describe our services using RDF, and then we use drivers to invoke those services. But actually, we have to deal with many problems when describing such data or services. So we need RDF vocabularies to tackle with all these issues. And one of them is how to ensure privacy. So we have to describe how to connect to those data or open web services in a private and secure way. So we need these RDF vocabularies. But we can go even more further. We can join the semantic web memory and semantic web calls and use some variant of GeoSparkle, because GeoSparkle is a language which is extended by adding code. For instance, here you see this RDF predicate, but in GeoSparkle you can use some function here, for instance, to check whether this point is inside a polygon. And actually my idea is to bring a code here into Sparkle as well. And by using this approach, we can come closer to the LNK's vision of the web as a computational infrastructure. So not just data, but also code. But there is a problem because we need funding, and I am going to apply for the Horizon Europe project. So if you're interested to participate, you can write an email to contact@webapps.org, and we will discuss how we can apply for that project. So that's all. And here is my Telegram, and now I am open for your questions, if any.
Thank you very much. I'm sure that your call for cooperation has been heard, and I hope that this conference generates future synergies. I have received a question for you. What are the strengths of Web App OS compared to other free web-based operating systems?
Okay. So this operating system uses an innovative web memory approach. So you don't need to synchronize memory. It is synchronized automatically. And it is synchronized in a very fast way. So actually, the encoding of memory is the same as at the server. So we don't need to convert that memory. It just is synchronized seamlessly, and you can access it from any network node. This is one strength. Another strength that this web app OS can be used to invoke code at different nodes. So you can invoke JavaScript at the client side, or you can invoke Java or Python or other programming languages at the server side. So this code agnostic approach is also one of the strengths of this web app OS.
Thank you very much, Sergey. So I think that definitely clarified the strengths of the system. Thanks, and I think we can continue our trip through innovation with our next speaker. And I would like to invite Samantha Alipio to join us. Sam is from Wikimedia in Germany, and she's going to be talking about Wikibase. So, Sam, are you there?
I am here, and I'm going to try and share my screen now.
Hello, and welcome. And as soon as your screen is out there, I'll hand over the floor to you. Very good. Thank you.
All right, I can go ahead and get started. Hi, everybody. I'm so happy to be here to talk to you a bit more about Wikibase, specifically using Wikibase to connect and collaborate around structured data. Brief introduction to me. I am the product manager for Wikibase at Wikimedia Germany. I'm not here as a technical expert on the software, but as the product manager, my role is around setting the direction and strategy for the product, defining the roadmap for the product, and collaborating very closely with the community. If you're not familiar with the Wikimedia movement or Wikimedia Germany, we do tend to collaborate very closely with the community. We practice community-driven development. So my role is very hands-on and speaking to a lot of different stakeholders and users directly. So we'll start with the basics. What is Wikibase? If you're not familiar with it, it's the free and open source software that powers Wikidata, which you might be familiar with, and several other projects as well. And I will give you lots of details on some of those other projects. But it all started out with Wikidata. So back in 2012, Wikidata started. It is a Wikimedia project. Another Wikimedia project you might be familiar with is Wikipedia. It's a free and open database that stores structured data on the world. It is a very vast general knowledge graph. Currently contains more than 92 million data items, and there are more than 25,000 active editors on Wikidata. So that's more than 25,000 people who contribute more than one edit a month to the platform. So it is very collaborative by design. And all data on Wikidata is available under a CC0 license, so Creative Commons, meaning it is freely reusable and not protected by copyright. I will give a brief plug that if you're very interested in the topic of Wikidata, my colleague Lydia Pincher, who is the expert on Wikidata within our organization, will be giving a talk later today as part of the evolution track, I believe around 5:10 p.m. But Wikibase allows you to download the software, install it, and use that software to create and manage your own linked knowledge base, similar to Wikidata. It's a very flexible software, which allows you to build a data model that suits your specific needs and your specific collection of data. There's no data model that is imposed upon you. And it is designed so that you can easily access and update data within the user interface. You can also export that data in a number of formats, depending on the purposes that you're going to be using those exports for, including JSON and RDF. And finally, to round out the functionality of the software, there is a Sparkle endpoint so that you can query your Wikibase instance to uncover insights or produce visualizations or other things. To put it really simply, Wikibase is all about putting order around the things in your specific area of expertise. It's about making data readable and queryable for humans and machines. And it's all about doing things the Wiki way. So similar to Wikipedia in that it's designed to be collaborative. It's not just for a single individual to be the one owner and maintainer of data, but baked into the software are tools and features that allow you to have many people contributing and linking data together. So you might be asking yourself, after that very brief description, or after knowing a bit about Wikidata, if Wikibase software itself is a good fit for you and your project. And there's some characteristics that would make one a good candidate for Wikibase software. If you have structured data that is a bit specialized and you'd like to be able to express it with a flexible data model that is also editable and customizable, Wikibase could be good for you. If you know that your knowledge base is going to be read directly by both humans and interacted with by machines, such as bots, Wikibase is also a great fit. It's, again, looking at the Wikidata example with the sheer volume of people that are directly contributing to the platform. It's a great tool if you have data that is going to be edited and maintained by several collaborators. And on a similar note, if collaboration in a multilingual setting is crucial for your project, then Wikibase is also a good fit. That's, again, a feature that's built into the software. Every entity within your Wikibase can have labels in as many languages as you want to add. So if you have a project team that operates primarily in English, but you're dealing with the data that you would like to be able to localize into other languages, you can do that within Wikibase. And finally, I'll be sharing some examples with you a bit later around specific ways that Wikibase has been proven to be quite good for catalogs, authority files, particularly within the library space, controlled vocabulary, and some other very interesting projects. So when we talk about Wikibase, both as an organization at Wikimedia Deutschland, as well as within the community of Wikibase users, we tend to refer to it as an ecosystem. And I'll just clarify a little bit that ecosystem is kind of our metaphor for things that are to come. At its most basic level, this ecosystem refers to all of the different knowledge hubs that exist within the world of Wikibase. So the largest at the moment is, of course, Wikidata. It's a very well-established community. It contains a significant amount of data, and there are other knowledge hubs that are springing up within the Wikibase ecosystem. One space that is of particular interest is that of the national libraries, and I'll share some specific examples in a bit. We also have other institutions in the arts and sciences that have set up their own Wikibase instances as a way of storing information on their collections or research data. But in the long term, the goal for Wikibase is not only for it to be an ecosystem of knowledge hubs, but also a more holistic ecosystem as well. So we've been putting in efforts as an organization to help develop a network of service and support providers, because yes, it is free and open source software, but very often within an institutional or organizational setting, you might have specific needs for customization, and connecting with service providers in that space is very important. Other members of this ecosystem can include hosting providers, and then a bit further down the line, as the ecosystem matures, the dream is for there to also be a collection of complementary apps and software that are able to plug into Wikibase to make it even more extensible and customizable. And just to give you a high-level overview of what this Wikibase ecosystem in terms of the knowledge hubs side looks like today, we have had great traction since the earliest days of the Wikibase project in the world of GLAM, which is galleries, libraries, archives, and museums. Particularly in the library space, Wikibase has been shown to be a very viable option for the hosting of authority files, for modeling bibliographic data. We also see great interest and success from research projects in the sciences, some recent happenings in the world of government and policy, with the adoption of Wikibase for open government linked open data projects. And yeah, lots of other kind of various interesting projects have been springing up as well. It's a very diverse group. And I think that this is a testament to just how flexible the software is. It can fit a number of different use cases. And the interesting thing is, if you take a look at this pie chart, you'll see that in terms of the sheer number of Wikibase projects or instances that are out there, the Wikimedia projects, which is where Wikibase began, right now make up only about 6.5% of active Wikibases. So that would include Wikidata itself, as well as Wikimedia on Commons, which is a repository of open sourced images. So while they might contain more data as a proportion of the ecosystem in terms of the number of instances, Wikibase is definitely very well represented outside of the Wikimedia movement, and that is definitely growing. Great, so I've been speaking a bit in the abstract about what Wikibase is and what it might be good for, but I wanted to share with you some specific examples of really interesting projects that have incorporated Wikibase into their workings and achieved very interesting things with them as well. So the first project that I wanted to share with you is enslaved.org. The Enslaved project is formed around this idea that there are a lot of gaps in our knowledge of the historic slave trade. There are no ontologies or data models that lend themselves easily to really understanding the lives and experiences of the people who were a party to that historic slave trade or who were victims of that slave trade. So Enslaved is a linked open data platform that contains at the moment over 750,000 records. That includes peoples, events, places, and sources. And by using Wikibase as a shared platform, the Enslaved project is able to take several long-standing legacy databases, combine them together, and preserve that data for future generations. This is an amazing project. I'm really excited about it. It was many years in the making and finally launched to the public in December of last year to great fanfare. There was an article in the Washington Post, and I just think that this is an amazing example of how underrepresented knowledge can be well represented in Wikibase software. Next up, we have the German National Library. So the German National Library is one of the earliest institutional adopters of Wikibase software. They have been piloting Wikibase for their integrated authority file, also known as the GND, which represents and describes entities that are used in the cataloging of written works. This authority file is authoritative across the German-speaking world. And by using Wikibase as a platform for holding and hosting and managing that authority file, the hopes is that this can both serve as an example for other national libraries, as well as institutions in the GLAM space who might have similar needs. Next up, so we've talked about a historical research project, we've talked about a national library, now we have FactGrid, and FactGrid is so cool. So this project started out as a Wikibase that was used for holding about 10,000 different documents related to the Illuminati. And I know when you hear Illuminati, you might be thinking immediately Dan Brown novels, the Da Vinci Code. But this is actually referring to a secret order that existed between 1778 and 1788. So by using Wikibase, they were able to make connections between different members of the Illuminati, who corresponded with whom, from what locations, at what time. This project has kind of evolved into a collaborative database that researchers in the digital humanities can sign up for and share. I believe today there are almost 150 participants from around the world who are using the FactGrid infrastructure for research projects in the digital humanities space, which is, again, very exciting. And then finally, we have the Linked Jazz project, taking it in a completely different direction. Linked Jazz is part of the Semantic Lab at Pratt University in the United States. And they're using Wikibase as a way to explore linked open data for exposing relationships between members of the jazz community. So by taking jazz historical data from a variety of sources, including archives, museums, and libraries, they're able to make connections between different jazz artists, seeing who played with who knew whom, and who might have been influenced by whom, to add some more detail and enrichment and color to the lives of these musicians. So as you can see, there are a lot of different things that can be done with this software. And I hope that this has served as a bit of an inspiration for you if you're interested in learning more about Wikibase. Again, I'm not the technical expert, but I am certainly a representative of Wikibase as a product. I would say great resources for finding out more would be visiting us at our official website, which is displayed here on the screen. It's wikibase.se. You can also contact us at the email address displayed here, which is SWE_partnerships@wikimedia.de. That connects you to our community communications and data partnerships team, who can answer a lot of different kinds of questions for you, connects you to the right resources. And then finally, we do have a very active and really phenomenal user group of people who are using actively and exploring Wikibase. So you can go ahead and join them there. There's a Telegram channel that is very active. It's a great place to get pretty much any question you might have answered. And we also host once a month something called a Wikibase live session, where if you are curious to find out more about the kinds of projects that are using Wikibase, it's a venue for learning from others, sharing knowledge, asking questions, and all sorts of other great stuff. And I think with that, I can open it up to any questions that there might be.
Thank you very much, Sam. Thanks for a very broad and very indeed varied overview of the various possibilities. I'm sure you have opened up some new perspective to some of our audience. I have two questions, and I'll ask you to answer them briefly so that we continue sticking to our timetable and to our schedule for the rest of the day. The first question is, what's the difference between Wikibase and a triple store like Virtuoso? And the second question is, Wikibase repository is based upon JSON instead of the unstructured data of MediaWiki wiki text. What are the advantages of JSON?
So I have good news and bad news. I'm going to probably be able to give a nice vague answer to the first question, and to the second question, while it's a phenomenal question, I'm probably not the right person to answer it as a non-technical representative of Wikimedia. But as for the difference between Wikibase versus another triple store such as Virtuoso, some of the things that I highlighted. So structured data in Wikibase is stored also in triples, and our triple store is BlazeGraph. One of the things I think that sets Wikibase apart is the ability to interact directly with the data and edit/view it within the user interface in either a singular way or a collaborative way.
Okay, well, I suppose for the question related to JSON, the person who raised it can probably reach out to some of your colleagues via that email that you indicated in your last slide.
Absolutely, and I would be very happy if they would do so, because I would love to get them an actual detailed answer, for sure.
Very good, thank you. I'm sure they will. The message got through at least. Thanks very much, Sam. And I would like now to end our afternoon with 3 practical demonstrations by our next 3 speakers. First of all, I would like to invite Lucie Wallin and Anniko Gerenche from the Publications Office of the EU to present VocBench.
Yes, hello everyone, and thank you very much for the introduction, Florence. So I will quickly share the screen and start with a short introduction to VocBench. I know yesterday some of you might have attended the workshop provided by the developers of the tool. So we are not going to go very much into technical details, just a short demo, a short use case, how we are using VocBench at the Publications Office. What are we doing with that? And Lucy is going to show you some features of the data. So let's go for, okay. Okay, so do you see the screen? Okay, good, perfect. Okay, so VocBench is an open source tool for managing controlled vocabularies, such as thesauri, taxonomies, but also ontologies, glossaries, authority files, authority tables, so any kind of structured controlled vocabulary. It was developed by the University of Rome, Tor Vergata, funded by the ISASPHERE program of the European Union, and the Publications Office is leading the development of the tool in collaboration with InfEurope. We are sharing the access of VocBench internally and externally. Internally with the teams and projects of the Publications Office, and externally we are providing the corporate access to EU institutions, member states, international organizations. It's a collaborative platform, so you can see some features here. It's web-based and open source. So basically, you just need a browser to access the data. It has a collaborative built-in workflow. We are going to guide you a little bit in the features later on. And is designed for managing large-scale multilingual vocabularies. It's accessible in any language, and it uses semantic technologies. So the data is based on RDF, modeled in SCOS, all Ontology for glossaries, and it has a Sparkle editor and Shackle validator as well. So I will quickly stop sharing this and let me know if you see, sorry. Okay. Because now we are going to go to the interface itself. Okay, here, and let me share. Okay, so let me know if you see the screen. Fine, okay. So this is the main interface of VocBench, where you can see the list of projects. So they are named in OR access by the name of the institution and then the name of the vocabulary itself. As for the tools, you can see that we were speaking about the collaborative workflow. It means that it has two very good features, the history and the validation. In the validation, you can see that if you did anything, any changes on the data itself, it's marked as pending, and then you can approve or reject it. So for example, here, the admin, so this user added an alternative label to a concept, and you can see it in the literal values. You can also expand it and see what are the pending actions, and later on you can accept or reject this in the validation. So it's actually approving this 4i principle, so more people can work on the same project with different user rights, and we can also share the collaboration with the colleagues, so we can validate each other's actions. Everything that was validated is seen in the history. So here you can see all of the actions that were done over the history of the project. So it gives you an overview of what was changed in what date by whom. Still, for the collaborative workflow, in the administration, you can see the list of projects with every user assigned to that project and the different user rights. So, for example, we can have lurkers who have read-only modes. We can have mappers, ontologies, and so on. But Lucy is going to go a little bit into details about this. I just want to show you a little bit the other features. So, in the export and the import, you can load and export the data in different formats. You can select based on RDF, XML, different lexicalizations, and then you can download and save your files locally. The same applies also for the load of the data. And in the other tools, you can see the Sparkle editor here and different other tools regarding the metadata, the import of ontologies and namespaces, validations, custom forms, integrity constraint validators, SCOSD things. So they are more technical, and I'm sure that they were explained more in details yesterday. So I give the floor to Lucy, and I stop sharing. She will show you some other graphical design features.
Thank you, Aniko. I will share my screen now. Tell me if you see it. Okay. So here in the concept, we can have several properties. So the first one is the URI, which is automatically affected by VocBench, as you can see here. We have other things such as the broader term. Here it is wildlife for animal life. You can see the structure here. And we have also the pref labels. So they are in the 24 EU languages, and also the alternative labels, which is like a synonym. We can have also a scope note, as you can see here, in different languages as well. We could also have definition. You can also see the source of the definition. We can also add images from Wikimedia. And that's it for those labels. We can have, as it is a tesseract, we have a different relationship between concepts. Here you can see the broader term, but they can also have narrower. You can see it there. Okay, so yes, that was it for the different properties. We have also some nice features such as the data-oriented graph. So here you can see the different properties of each concept and the relationship between them. So you can change the strength and the length of each properties. You can take a snapshot of it and download it. So we have also different type of projects. Here is the country authority table in which we have different properties. So for instance, for East Germany, which is a deprecated concept, it is, as you can see, replaced by Germany, and it has a start and end date, as you can see here. We can have also links between different projects. So for Belgium instead, we have different languages. And here is the URI of the authority table language. So, okay, so that was it for the different properties that we can see in each concept. We can also link and map different project between them. So we can align it with external projects. You only have to add the URI here, and you can choose the different properties to use. So either you can do that for each concept separately, or we have a different tool to do that, and you can perform all the alignments in one time. Okay, so that was it for the VocBench demonstration. Thank you everyone for your attention, and you can get in touch with us using this email address, OPEU Vocabularies.
Thank you very much, Lucy and Aniko. I see in the chat that there's a couple of comments for the moment, but no question, but maybe we will see at the end of these three demonstrations whether we have questions for some of you or not. It's probably better to continue. And I will therefore invite our next two speakers who are going to talk about this PMKI platform that was mentioned earlier on. So I'd like to welcome Nadje Hajlaoui and Denis Dechandon, who are both also from the Publications Office of the EU. Nadje, Denis, are you there?
Yes, I hear you.
Yes, hello, good afternoon.
Hello.
I don't see you, but I'm sure you'll appear very soon.
Now I think you can see me.
No, okay. Now, yes, now I see you.
Yes.
Okay, so if you'd like to share your screen, please.
Sure. Did you see it?
I'm sure it's coming up. There we are. Yes, if you put it in, that's it. So over to you.
Thank you very much. So I will talk about PMKI platform, and this is good that it became after VocBench presentation, because as you will see, it's very related to both projects are very related. And maybe some of you heard about PMKI platform, some of you know it, some of you are waiting when it will be available as open source. As you might know, this this project started in 2015 and exactly 2016 after the big event in Latvia about multilingual web summit, where the European language technology industry, lobbied by Innovate in Brussels, made a request to have an open multilingual knowledge platform where to share at the European level, let's say in general language resources, to collect them and to share them. So, and even they proposed a common architecture for the multilingual digital single market where this platform appears. So, yes, no, second slide. So what are the objectives of the project, PMKI project? As you know, it started as ISA Square project, and with collaboration with our partner, other DG from European Commission and European Parliament. They are on board of the steering committee of the project. As you know how it works, it started at ISA Square project to prove the feasibility of the project, and then it went after validation in 2019 through a dedicated workshop and where the external expert approved and expressed the strong interest to have this multilingual platform where to share terminology and semantic assets. So it's to have this repository at European level, where a place where to share, and not only to share, but also to align language resources and multilingual assets. So of respecting and after analysis, we proposed a common data model for that can be respected for all these multilingual assets with, as you will see, the possibility to convert from other format to this recommended format. And this is based on the recognized standard, and proposing also and offering the possibility to align data sets between them. As this is, in fact, is a web interface where we propose a certain number of services. The first one is the possibility to browse the content, to see the concepts, to see the terms, to see the relationship between them, with the possibility to have a graph visualization of the concept, but also of the data set and the relationship between them. The possibility to align between data set, and here we included several algorithms, and even we have collaboration of with Jean Maigret, who presented previously. He have a nice alignment tool called Nasha, and we have also our internal alignment system for that. But also this platform propose or offer a Sparkle endpoint to retrieve data set and to be connected also to other platform like the European Commission Machine Translation Service, where we developed a specific API for them to have parallel data to enrich and to improve the quality of machine translation service. So in global, this is the main compound of PMKI, and it makes use of VocBench, which was presented previously, to manage these multilingual assets as it is made for, but also improved by a certain number of features, such as the alignment, the validation of the alignment, the multiple visualization view, including the graph visualization, and with the possibility to share and to make them public or not, and with the possibility to convert from other format to the recommended format. All this is also managed by, of course, we need a dashboard to follow up and to manage all the contribution of the users. And for the demo, and since we have a very short time, and we think that it's better to show you some screenshots like that, we can show you more information and more functionality of the PMKM platform than to do it online, because as you will see, for example, this is the main and welcome page of PMKI, and to contribute, the user can send a request to contribute, and here we need to enter the name, the first name, the address, email, etc. A certain metadata take time. That's why it's ready as screen shot. A certain metadata about the resource that the user wants to upload and to share, like the base URI, the model, etc. Confirmation that the request was submitted, and now it's for the administrator to approve or to decline the user request to contribute. A confirmation of the metadata related to the data set. And when it's approved, the user receives an email with a link to load the data. Here, the screen to attach the file. In general, it's RDF or whatever format. And we have a confirmation that the data was loaded successfully. Then it's now to the project manager to make them public. And this is, for example, for the land and water data set. When it is made available, there will be an alert that it will be visible for all the visitors, and an index will be created. And here a view of the data set. This is the list of concepts of the data set, and we can have a collection view, which is a flat list of the concepts, or a schema, which is a topic-oriented view of the concepts. So we can select a given schema, and we see the concept that belong to that schema. If we can select more than one, if it is the case, we select more than one, the union of the concept that belong to all of them will be presented. The property is the property of the knowledge model used, and the alignment is the alignment of the data set with others. Here we can make a search, for example, for the word water in this data set, and here the results will be presented like that. We can, here another example of data set is Eurovoc, and here we have the concept politics available in all the available languages in Eurovoc. And we can, using the dashboard, we can use or limit to a certain number of language, like here politic in here in all the available language, but after we'll see that we can limit to French and English. Here we have a graph visualization of the concept, and if we click, we can expand it, double click by expand, as shown by my colleague in the previous demonstration. So it's the same graph visualization, the same methodology behind it. Here, another graph representation of the concept with limited to the English and French here is administrative law. And if we see the graph visualization, we can see that it's more, sorry, there is what happened? Oh, sorry, yes. And we can see that there is more connection with this concept. By double click, we expand it. We can play with the strength and with the length of the graph. And we can make here another type of search through all the data set. For example, law, it exists in EuroVoc, but also it exists in other data sets. And finally, about the alignment, here we can select a source dataset, and we can see in a table view all the dataset related to, or that have an alignment between concepts with other with gamete here as selected as source dataset. We propose also graph visualization of that, and here, for instance, it gives us an idea about the similarity, let's say, and or about the distance between one data set and the other here, gamete, between gamete and the proportion of EuroVoc, because it is a cut, there is 9038 links.
I'm sorry, Najee, we have lost your screen. I don't know if you're still sharing new slides with us, but we don't see your screen. And then also I'm going to have to ask you to wrap up because we want to save a little bit of time for our last speaker. So if you could quickly conclude, please.
Did you see my screen now?
Yes, now we see it, but not in full view.
Okay. You see it. So I was just showing this search possibility through all the data set, for example, the word law, and it will show that it exists in several data sets. And above the alignment, we select a source data set, gamete here, and it will give us all the links between with other data set with the possibility to have a graph view of that. It gives us, as I said, an idea about the similarity between data set and the distance between them. And finally, the SPARQL access, here an example directly to search or the concepts that have pref label with economy as literary form, and the results by double click on that give you that. To wrap up, PMKI is almost here where we are in pre-production, let's say, simply because we are still in testing phase. We have 3 phases of the testing, acceptance, and production. We are in acceptance now, and very soon we'll pass on production. It offers collaborative work with the possibility to share multilingual assets, possibility to align data set, several possibility to visualize and to browse, and to make search through the data set or all the data set or a given data set with possibility to SPARQL access. Thank you very much.
Thank you, Najee. Thank you very much for this demonstration. And on to the final demonstration of today, and I'd like to invite Bernhard Krabiner from the Center for Public Administration Research in Austria to make his demonstration about Semantic MediaWiki. Bernhard, hello, good afternoon.
Yes, hello, good afternoon. Thank you a lot. We only have 3 minutes time, so
It's okay, you can take 5.
Okay. I will talk to you about Semantic MediaWiki. Let's be quick. What is Semantic MediaWiki? It is an open source project. You can look it up. I would consider it as something as a Swiss Army knife for data and semantics. It is built on top of MediaWiki, on the MediaWiki ecosystem. So that's the wiki engine that powers Wikipedia. But it can be used for much more than just wikis. What I mean, I will tell you in a minute. When talking about linked open data, you all know this 5-star scheme. You have to beware if you use MediaWiki, you are perfectly fine displaying information and data on the web in an open license. So there is support for that. But if you want to move on in the 5-star scheme, you have to use Semantic MediaWiki in order to have structured data or also RDF and linked data. Generally, I would say there are two types of user domains for Semantic MediaWiki. One is not so interested about semantics at all. They are just maybe database-oriented users. So they want a flexible web-based database system for managing text and alongside with structured data. So you could consider it as a kind of a web-based Microsoft Access, where you want to have an online form that users fill in data. You want to provide some overview on the data, some queries on what has been entered. Semantic web standards are maybe on top without a specific use case. So yes, you have an RDF output, but people don't really often know what is RDF. But they might be interested in open data. So exporting what has been entered in the database in JSON or CSV could be interesting also for those users. And of course, we have, and probably now the people here are more from this community, the semantic web community or the knowledge graph community. So they might want a kind of a Swiss Army knife. So this tool that can do a lot in the semantic web, not everything perfect, probably, but a lot is already in there. They need RDF export, of course. They want to reuse external vocabularies, full vocabulary or others. They want to import or export data, or they want to implement knowledge graphs, maybe in their organization or for their research purposes. So what are the main features, quite briefly? Everything is a wiki page. So for example, if you have a page about Vienna, this page can have properties, number of inhabitants, is located in, has coordinates, maybe also a Wikidata ID that you want to reference to. All these properties here also are wiki pages. So you have a wiki page coordinates, for example, and then you would say this is of type coordinate. Or you can have text properties, number properties, date properties. You can have a property like external identifier that would link, for example, to Wikidata. You can reuse external vocabularies. If you say, for example, that in my wiki, I'm organizing persons and they have the property last name. I want to call it not last name, but it is actually imported from FOF family name. So it is the same as FOF family name, and it would be represented in the RDF output in this way. Then you can do that. This is for the professionals who set up your environment. For the users, you have an easy form-based entering of data because they want to populate the knowledge graph that you're building. You can import data. You can query external APIs. You can export and display data via result formats. And this is, I guess, a very important distinction to, we heard before about Wikibase. Wikibase is also an extension to MediaWiki. But in Wikibase, you need a triple store in order to be able to query your data, an external endpoint. Semantic MediaWiki has a own simple querying language that would present the users on specified wiki pages with queries that can be formatted in a table, that can be exported in a certain format, that could be a calendar, a timeline, a map, a tag cloud, or whatever. And Semantic MediaWiki can also be configured to offer triple store support, and it has an API where you can query data out of your instance. So it really builds on top of MediaWiki. It has all the great functions that MediaWiki makes so special, the collaborative editing of texts, the structure via categories and namespaces, the version history for every edit. There is no back end to be learned by the user, so everything is a wiki page. There are hundreds of further extensions or skins, etc. And there's, of course, a very large community with the Wikimedia Foundation also making sure that the MediaWiki core is continuously developed. So this is a short example, maybe. You can look it up later. It has been done for the Austrian Academy of Sciences. It is about ancient scholarly communication, so letters from numismatists. You have a visualization of the letters. You have some metadata about the person. You have some pictures. You have the export format. You have a map of birth and death place. You have the literature from this person and further references. So just to give you an overview, this is a specialized wiki setup for this use case. I would, if we have some time left, we actually don't, but I have prepared a live demo. So maybe I can show you a little bit more. Of course, here's my contact information. Do we have? Can I take a minute to go in the live demo?
Yeah, if you take a minute and a half, that will be okay.
Okay. This is a MediaWiki installation that is pretty empty, so there's not much in there. You can look maybe here, an example of Vienna. There is some data, and you can, if you want, display a fact sheet about Vienna. So all the data that is not only text but has been semantically annotated. So you have, for example, coordinates here, or a Wikidata ID, or the size. And if you look on this property, also the property Wikidata ID is just a wiki page where you define, if you look at the source code via wiki text, the property is of type external identifier, and it has a certain URI that is used to link, and it can have labels. So if you click here on this Q number that is entered, then you would of course go to Wikidata. A regular user, maybe this is a nice addition now. In a talk at the first conference day, there was a talk about a data catalog. What's the difference between a data catalog, a data dictionary, and a business glossary? I think Semantic MediaWiki could serve as all three. Here you can see an example of a business glossary where you would highlight some kind of term, and you would go to the definition of the term. And here you can see how a user would enter this via a simple online form where you can select additional terms, maybe have a glossary definition and save it. So this is all that the regular user sees is a form, and this will be highlighted here. So yeah, maybe this was the quick overview. You can have something like a map of cities, of course. If you want to display all the cities on a map, then you can have this, or you can also do something like cities on a timeline, an interactive timeline. And this is also done within wiki pages. So this is a very simple query. Show me all the wiki pages of the category cities and display it in form of an interactive timeline. So this is how you can use Semantic MediaWiki for all sorts of use cases, and it has the capability of also storing everything in a triple store. Yeah. So if you're interested, please contact me or join the Semantic MediaWiki community. It's a very vibrant community. Thank you very much.
Thank you, Bernhard, for being so brief in your presentation and your examples. So, ladies and gentlemen, this brings us to the close of this track 3. Since tomorrow there's no track 3, so that's it from me now. Thanks very much for following us over those 2 afternoons. Thank you to all of our speakers. I believe that today we've had a lot of very concrete, practical examples, ideas, suggestions, solutions, proposals, projects. So I hope that you will all get something very concrete out of it, and you will be able to use it in your daily work. I'd like to remind you that all these presentations and the recordings of the sessions are going to be available from the Endorse website next week. So look it up or look them up. and feel free to share further. And finally, our Slido question, and this isn't the survey that we had throughout the afternoon, this is the question calling for suggestions, is open now. So as you close your screen, you will have this pop up. Please answer our Slido survey before you leave. Thank you very much, everybody, for following us, for being there this afternoon. And to all of our speakers, again, thanks for very vibrant presentations and for sharing your passion. Have a very nice evening, and most of all, stay safe. Thank you. Bye-bye.